Evolution is false. I believe it's demonstrably false. And if you disagree, then I invite you to come and share your evidence for evolution. And a lot of people have the question, well, if evolution is false, then what about all of these scientists that believe in evolution, all these smart people who believe in evolution? Well, I can't speak for all scientists or all people who believe in evolution, but I do see one main reason that causes people to believe in evolution in spite of the massive amounts of evidence against it. And that is they've accepted the idea of naturalism. They've embraced the idea that everything that we see has come about by natural processes. And it's their commitment to that idea that causes them to accept this ridiculous idea that things have that life came about by natural processes and evolved and diversified into the diversity of life that we see today. Now, I invite challenges to this, and I was ready to share with you some evidence against evolution, but we already have a guest that is joining to share evidence for evolution. So let me welcome him. Hey, Dr. Thomas, how are you?
I'm great. How are you? It's Thompson, by the way. That's okay.
Oh, I'm sorry, Thompson. Sorry
Not a
about
problem.
that.
That's okay. We all make mistakes. Yes, I'm great. How are you doing tonight?
Good. Thank
Good.
you.
Yeah.
Yeah.
So you started off with evolution is false. I'm curious why you might say that, because I feel like there's actually a fair amount that we probably agree upon, which is that there's been, at the very least, some evolution, like the evolution within kinds. So I was actually hoping that we could talk about that if you'd like. Does that
Well,
sound good?
yeah, I mean, if we're we have to really kind of get clear about what we mean. And I try to be clear that the definition of evolution that I am saying is wrong and false is the idea that life developed and diversified from a common ancestor by natural processes.
Yes.
So I'm okay. I accept, I embrace the idea that organisms change.
Yeah.
To a degree, and there's mechanisms that we see that can cause organisms to change. But the question is, to what degree can they change?
That's and right. I think that there's a lot that we can discuss about evolution within, say, at the family level, and maybe at the order level, that can be really informative to how evolution beyond the order level actually occurs. And I'm happy to kind of go through what I think is some of that evidence. Now, I also think that another important aspect of understanding evolution and the evolutionary theory is the evolution of novelty, right? That natural selection and other natural processes can give a rise to novel structures and novel features within organisms via a natural process, and that we don't have to hearken to non-natural processes such as magic to explain these things.
Okay, cool. Well, I look forward to seeing your evidence.
Sure. So why don't we get into it? Some of this may be a little redundant for people who've seen some of my debates, but I happened to see that you were doing this, and I thought, okay, well, why not go with the hits if we know them? I actually have some slides I could share.
Go for it.
To
Pull them up.
explain this. So let's see here. One moment. All right. I think we can. I mean, I've talked about dogs in the past, and I think we can probably talk about dogs again. It does not hurt. Everyone loves dogs, right? So let me get my slides over to you. Share.
And we have a good question for you.
Yeah.
Pigs Can Fly says, Dr. Thompson, can you provide a mechanism for the formation of novel functional gene sequences in any genome?
Can you provide a mechanism for the formation of novel functional gene sequences in any genome? So I suppose it sort of depends on how you define novel, but in fact, that's actually something that I hope to get into.
Okay, cool. And
Yeah.
I
Mhm.
do remember I have seen some various videos and debates with you, but I don't remember what your credentials are, like what your
Oh,
field
sure.
is.
Oh,
What
yeah.
what
Happy
area do
to.
you work in?
Yeah. So I'm a neuroscientist. And
Awesome.
yes, so I do neuroendocrinology and neurotoxicology. So I'm primarily interested in how environmental toxicants affect the development of brains. And I'm particularly interested in how they impact how thyroid hormone works within the developing brain. Um, I obviously depend upon our understanding of comparative anatomy in order to sort of understand how this phenomenon might affect how humans develop. I use animal models to do this. So, of course, I depend upon looking at the shared genetic features of the animal models that I work with in order to better understand how the toxicants that I work on may affect the human condition. And the fact that nearly 85% of the genome of the animals that I work with is virtually identical to the protein coding sequences within humans makes that actually quite a valuable tool.
What a wonderful God who gave us the ability to do that. Okay, so
Okay.
here's your slides.
Yes. So let's see. We, I think, would agree that dogs and wolves share a common ancestor. In general, most young Earth creationists accept this. I've met one who does not, but most do. And there's
I've
good.
never looked into this, so I
Oh,
I don't know. But
you're
I mean,
completely.
it
Oh, so you're
it
completely
sounds
agnostic to
reasonable.
this idea that dogs and wolves share a common ancestor.
I mean, they certainly share very similar features, so it
Mhm.
wouldn't surprise me if they did.
Okay. Um, Interesting. Yes, they do share similar features as we're looking at right here. The domestic wolf and the domestic dog and the gray wolf are actually quite similar. Now, a lot of this is actually based upon some evidence, right? And let me bring up my laser pointer here. Uh, a big part of the evidence isn't just so much that they share morphological features, but the genetic evidence. If we look at the genomes of dogs and wolves, there's an enormous amount of overlap, that they're very, very similar to each other. The other thing that we know is that there's a basic substitution rate that occurs in both dogs and wolves. And that substitution rate, which of course is dependent upon mutation that then gets fixed in the population, shows that there's been a divergence between these two populations. That the domestic dogs and wolves must have shared a common ancestor around 30 to 40,000 years ago. So there's been divergence of those two populations. It's the only way that we can explain the difference in the genetics of these individuals is that there must have been a split in the population with some admixture occurring, of course, and that's fully consistent with the genetics. And so here's a study here of the showing the dog genome. This was a big study that was published in 2005. So just to kind of back up there, now when you say that you're agnostic to the idea that dogs and wolves share a common ancestor, is that because you just haven't looked into the genetic evidence, or is it because you are skeptical of this notion that shared genomics and shared genetic information is an indication that there is a shared ancestry?
Well, I think that there's a lot of shared genetics of things that don't share a common ancestor.
Well,
So,
and my contention is that all organisms share a common ancestor,
right,
but
I
there are
understand that.
certainly
And yeah.
that's the thing. I'm trying to see if we can find like a ground truth. Like for instance, well, let me back up a little bit. So I'm actually going to pick a different slide to start with. So, okay, can you see this? Yes. So we use DNA sequences to trace lineages all the time. So my mom had 23andMe done not too long ago, and her last name is Carlson, her maiden name anyway, and Carlson is a Swedish name, and it turned out that of course so when she did 23andMe, they looked at her DNA and they found that a big part of her ancestry was traced back to Sweden. Big shock. Now, the reason why they're able to do that is because they can compare the genetic sequences of her to the genetic sequences of people who have a long standing ancestry in Sweden. And so it makes sense that, of course, that was the case. The next thing that we also found out from this is that it turns out that she has a lineage that goes back to the ancestors who came across on the Mayflower. So we have direct ancestry to some of the genetic sequences that are indicative of some of the people that came off of the Mayflower. And that sort of made sense because we also knew our family history was like goes all the way back to sort of the Rhode Island, Connecticut area. And so it turns out that indeed the genetic evidence shows that that's the case. So it's an evidence that that's the case. Now, do you think that this is valid evidence that like my mom shares common ancestry with people who also live in Sweden?
Absolutely.
Okay. Why do you accept that?
Well, I accept the common ancestry of humans.
Oh, okay. Right. And that genetic evidence shows that she shares common ancestry with people in Sweden and
Right.
not say like a more recent common ancestor with those individuals that say were in Asia or say Native
Exactly.
Americans, for instance. Right.
Yeah, she has shared mutations with those
Right.
people. Yeah, with the people that she
Mhm.
descended from. Yeah.
Yes. Now, the thing is, of course, within human beings, there's greater genetic variability that we see amongst humans than we do between dogs and wolves. What does that tell
Cool.
you? Yeah. Do you think
Yeah.
that then wolves and dogs share common ancestors?
Well, I mean, we don't know that, do we?
I
I
think
mean,
that it's
so
consistent with like
and I've
I didn't see
heard
my
this
mom.
argument before.
Yeah,
I've heard
like I didn't see my mom have like so I wasn't there in Rhode Island in the early 1600s when people came over from Europe, and I don't know like the other ancestors that also obviously came over from Sweden because it turns out those were not British, those were British ancestors, not Swedish ancestors. Like all these events are just simply being intuited and deduced from the genetic evidence.
absolutely. Yeah.
Right. Yeah.
But let me get at where I'm coming
Mhm.
from. You have an origin story, okay?
Yeah, yeah, right.
You believe that we descended all from a common ancestor billions of years ago, right? And I don't believe that origin story. I think
Right.
there's a lot of scientific evidence against that origin story. That's not the story that I believe. I
Yeah.
believe the story that starts with God created. And so, with my story, I believe God created human beings separately
Right.
from, other creatures. And
The other primates.
right. And
Right. Because you
so
accept that we're primates, right?
well, it's if you use a certain definition of primates and they have certain, features, that's fine. I have no problem with labels.
Right.
Okay, but I don't agree that we descended
Sure.
from an ape-like ancestor.
Right.
Okay,
But
so
do you at least accept that dogs and wolves share a common ancestor?
I've already told you I don't know.
Okay. Well, at
I
least
have
most
not
Christians
looked
do.
into that at all.
Yeah.
It seems
Yeah.
reasonable, so I wouldn't
Right.
have a problem with it,
Yeah.
unless I had a reason to have a problem with it.
Yeah.
But
So
you
that
said,
right.
but I know you. Let
Mhm.
me just because I know where you're trying to go. You're trying to say that well, there's more differences between humans than between dogs and wolves, and that's fine.
Mhm.
But it doesn't. Actually, I have no reason to think that there couldn't be more differences between humans and than between dogs and wolves, and still they have a separate ancestor. I'm not saying that's true. I have no
Right.
claim about the ancestry of wolves and dogs.
So I'm wondering what the mechanism would be for a dogs and wolves to have separate ancestry. What would be that mechanism? And
God
for them to
created.
also then share extraordinary similarity in their genetics.
God created.
You're
Is
saying
there any reason that God couldn't create animals that have similar ancestors? And by the way, we're kind
mhm,
of going on a tangent because I
yeah,
haven't even denied that they share a common ancestor. All I'm
right,
saying, I don't know. Okay. And
sure,
so I
right,
don't want to get into this huge, basically fight about I'm not fighting this battle. I don't have a skin in the game. I don't care
right.
if they have a common ancestor or not. It doesn't really matter.
I mean, it kind of matters if they do, because we're talking about mechanisms of evolution. And one of the best evidences for evolution is looking at more proximate, more recent forms of evolution. And then if we could go back and look at, say, fossil evidence that corresponds with genetic evidence, well, then we can kind of push it back further and further. So you want to start at the origin of life on Earth around 3.8 billion years ago. Well, it's obviously a really difficult for us to intuit the evidence for the molecular evolution for abiogenesis mechanisms, for which we actually have very little data to actually go upon. But we could look at more recent mechanisms and see if those mechanisms are consistent with what we observe today. If we go back just a little bit further and see, is that fully consistent with also what we are seeing today? If we go back a little bit further, then you can draw additional conclusions. We do know that individuals and organisms that we know share common ancestry, that there's some sort of substitution rate that occurs in the genome. That substitution rate is an informative molecular clock. In fact, I can kind of go to my slides because I even have molecular clock data. That this is the basics of a substitution rate, and this is how that works. So you can have a genetic sequence back in some sort of common ancestor. If there's been a split in a population, you'll have a substitution that gets placed into and fixed within a population. So say this T is converted into a G at this point, and in this separate lineage, that there's a T that gets a G that's converted to T over here, and then more and more of these substitutions accumulate. And then when we compare the sequence of from one lineage to the other lineage, we can see that some of these substitutions, we know what that substitution rate is. At least we can make very, very good estimates of what that is. Therefore, we can determine when the last common ancestor was between these two lineages.
Well, Dr.
Mhm.
Thompson,
Sure.
all of that rests on the assumption of common
Mhm.
ancestry. And I will
Yeah.
just let you know that when I look, I regularly see major problems with these molecular divergence dates that are come up with. In fact,
Hmm.
last week on my show, I shared an example of a molecular divergence date that turned out to be 40 million years off. Okay.
Okay. Where are you
So
talking about 40
the
million?
tomato
Like,
seed. I'm talking about a tomato seed and
okay.
the split between tomatillos were supposed to have split off and become a thing 10 to
Hmm.
9 to 11 million years ago, according to the molecular divergence dates. And then lo and behold, in 2017, we discovered a fossil tomatillo that's supposed to be, according to evolutionary timeline, 52 million years old. So,
Mhm.
so the molecular divergence dates are just sort of a little, it's a guess, right? And it's all a guess based
Mm.
on common ancestry.
It's not a
Now, let me say
guess.
this: I don't
Yeah.
think
Mhm.
this dog wolf thing is going to help you, because
Okay.
when we're talking about we're talking, you showed a picture of a dog and a wolf that look extremely similar, and
Right.
I have no problem with the types of changes that need
Sure.
to happen for those kind of differences. What you need to show for evolution is that evolution, the mechanisms of evolution, can produce something like a new organ, a new system.
Sure.
And
And I'm going to get
you
to that.
started out by
Yeah.
saying you have novel features, which this
Rebecca,
would
if
be
you could
really
just allow me to
surprising.
talk, I
Okay,
will get to it. Okay. I promise you.
go
But
for it.
we have to work backwards. So we got to start with the evidence and then work our way backwards. So, one thing about molecular clocks is that they actually correspond really, really well with fossil evidence. This is actually a really famous figure here illustrating the correspondence of divergences of major mammalian groups. And based on fossil evidence, and the number of substitutions within the cytochrome C gene. So this is the fossil evidence here. So based on fossil evidence, we have evidence that, like, humans and kangaroos, the last common ancestor for them was around 125 million years ago, long before the extinction of the dinosaurs. That's where the Meta-Eutherians and the Eutherians split. And the molecular data is fully consistent with that, and that those two groups of mammals have the most differences that we're going to find. And this is the thing: molecular clocks show a very consistent pattern of the relationships that we can see. Of course, this is also true within, like, the order Carnivora. Now, the thing that I wanted to get to, let me change over to my slides about the dogs. So we're talking about dogs here, and their sequence how similar they are, right? Extraordinarily similar genetically. And of course, you pointed out that morphologically, they sure look very similar to dogs. I'm glad. I understand that you may be skeptical that dogs and wolves share a common ancestor. The evidence is extremely strong that that's the case. We've got good fossil evidence as well as molecular evidence that that's the case. And the thing is, of course, if dogs of all kinds, such as even pugs and wolves, share a common ancestor, we can also then look at other groups of animals that look sort of similar, such as like the coyote. I could kind of guess that you're probably going to say that you just don't know if dogs, wolves, and coyotes share a common ancestor. It's generally the position of most creationists that they believe that all of the dog kinds were descended from a single pair that came off of the ark around 4,000 years ago. I understand that you are completely agnostic to that. I will just operate from the position of where most creationists tend to agree with the evolutionists, that we all agree that dogs, wolves, and coyotes share a common ancestor. Of course, that's supported by genetic evidence, and that's usually the way that this would progress. Just based on that evidence, and that evidence can come from phylogenetic trees. As I said, dogs and wolves have an extraordinary similarity of their overall genomes, and this is also true, of course, if you compare dogs and wolves and coyotes. But the interesting thing is, dogs and wolves are more similar to each other than either of them are to coyotes. Now, are you aware that dogs, wolves, and coyotes can interbreed?
Cool. I didn't know that about a coyote. Yeah.
Yes. So dogs, wolves, and coyotes can interbreed, which is, also some pretty good evidence that they probably shared a common ancestor. Right.
I accept that as good evidence.
Sure. And so therefore you would agree that even though we're talking about three different groups of animals, they at least share a common ancestor, and also that the genetic evidence clearly shows that dogs and wolves are more similar to each other genetically than either of them are to coyote. And that's what the
Okay.
genetic evidence shows.
I mean,
So we can
yeah.
keep going, right? So then you can compare a gray wolf and a coyote. So we know gray wolves and coyotes, they're similar to each other. They can even interbreed, but they're not as similar as, say, a wolf is to a dog. If we can compare it to a golden jackal, we can look at the how they fit within a phylogenetic tree. And it turns out that dogs and wolves are more similar to each other than either are to a coyote, but that dogs, wolves, and coyotes are all similar to each other genetically than either of them are to a jackal. And the thing is, you can kind of keep going on and on with this with all the different canids. There are 34 extant species of canids, the different dog kinds or wolf kinds. One of them is a bush dog. One of them is a Maine wolf. There's another one called the raccoon dog. All of these are different kinds, right? So that is the thing. Now, let me go to my slides again real quick. So this is the phylogeny of the wolf kind, right? Based on the genetic evidence. And of course, there's a lot of fossil evidence to support this as well. But essentially here, what we were looking at down here was the dogs, the wolves, the coyotes, the golden jackals. But then these other examples that I showed are animals that also share an enormous amount of genetic similarity to each other. Like, for instance, the bush dog and the Maine wolf, and the raccoon dog is over here, and the fox-like canids. All of these animals, though, are more similar to each other genetically than any of them are to, say, like a bear or a lion or a tiger or a cat. And in general, I understand that, Rebecca, you're completely agnostic to this, but most creationists would agree that all of these animals are descended from a common ancestor. And they accept, at the very least, that the genetic evidence is indicative of that. And also the fact that many of these animals can actually interbreed with each other.
Every animal on this chart?
No, they can't all interbreed with each other.
No,
but the
no,
ones that are
no.
most
I'm
similar.
saying, are
Yeah.
you saying that creationists accept that
Yes.
these? No, I don't. No, that's not true.
Really?
I
Okay.
mean,
Answers in Genesis.
look what's on your
Yes.
thing. Black
Yeah.
bear, giant panda.
Okay. I'm not talking about these guys down here. I'm talking about all
Okay.
these.
All right.
Yeah. The
Okay.
one up there. Yes. Right. No, these are the outgroups. So in any given phylogenetic tree, in general, you're going to include an outgroup, something that maybe is somewhat similar to those animals, but not part of the same group, and that's considered the outgroup. It's sort of like a baseline against which you can compare it. So no, I'm talking about all of these guys, right? These are all, and creationists generally agree that these are all related to each other. But we can even get a little bit more
I'm
specific.
getting the
Yeah.
feeling,
Mhm.
since you keep emphasizing creationists generally
Yes.
agree, that
Right.
you're trying to give me some evidence that's going to
That's
be
right.
specific against this view that creationists hold. So,
Uh, I suppose, yeah. I mean,
okay.
it's
Well, I
not
mean,
necessarily
so
that. I mean, I'm also talking about that this is evidence for evolution, that these are 34 different species with a lot of actual novel structures within them, and that and it's a point of commonality that creationists, at most creationists, obviously there are exceptions, such as yourself. You must believe that all of these organisms were specially created on some way, and
I
then they
don't
were all
have
in
a
there.
belief either way. I
Okay,
told you
gotcha.
I
Okay.
have no interest in
Completely,
trying to figure out
completely,
which
I got
kinds
it.
are which, okay?
Right,
Like, I
right.
don't have an interest in that.
No
But
interest in like when the creation occurred or how these organisms, for instance, you have no interest, like, let me just see. This is, if we can refer to the South American canids, okay, because I think this is a super interesting group. There's a lot of interesting things that happen in here. So there's a focus on the South American canids. There are 9 canids. What we know is that all of these canids were not, there were no canids in South America prior to around 3.5 million years ago. There's no fossil evidence of canids prior to that time. The canids evolved in Europe and North America. South America was separate from North America up until 3.5 million years ago, when there was the Great American Interchange, when South America finally collided with North America. We got great geological evidence that that was indeed the case. Then canids from North America traveled into South America. From there, they diverged into a number of different species, and some of them are really, really interesting. For instance, as I pointed out earlier, we've got the bush dog and the Maine wolf. These guys are actually more similar to each other than either of them are to any of the other South American canids. So these are sister species. But the thing that's extraordinary about these two species that are more similar to each other than any of them are to any other species in the face of the planet is that they have extraordinary diversity in their overall appearance. We know from genetic evidence that their last common ancestor was about 3 million years ago. This is also consistent with fossil evidence. Um, the,
again,
Mhm.
this is well, I have to stop you because
Okay.
you're basing this on
Yeah.
your assumption of common ancestry. So you
Well, do
have
you
to
have a
understand
different explanation
everything you're
for?
doing right
Yeah.
now is you're
Right.
doing your storytelling based on you think similarity shows common ancestry. And
No.
so you're
Yes,
building a story about how these are
Rebecca.
related. That's what you're
That's not what
doing.
I'm saying. No, I'm
Okay.
not basing it on just similarity alone. I'm basing it on genetic similarity, because you
Yeah,
can't
and that's
base
a
it on
genetic similarity.
morphological Yeah, you can't base it on morphological similarity, because what I'm about to point out is that morphologically, behaviorally, dietarily, these organisms are extraordinarily diverse and very different from each other. Yet they are more similar to each other than any other two organisms are on the face of the planet. Okay.
Okay.
So, for
And
instance,
so
the bush
how
dog is unique
yeah.
amongst South American canids. These guys live in dense forests and wetlands. They are hypercarnivorous. Now, most wolves actually aren't hypercarnivorous. What that means is that they totally depend upon meat as their diet. Most wolf-like animals are carnivorous, but they're not hypercarnivorous. They can eat other types of things. They're not totally dependent upon just eat meat, but the bush dog is completely dependent upon meat. They live in packs. They're very highly social. They actually have webbed feet, which also makes them unique amongst the different dog-like species. They have short, stubby bodies, and this allows them. They're highly well adapted for living in the kinds of environments that they're found in, which tends to be these wetlands. The Maine wolf, as you can see, it almost looks like some sort of fairy tale organism. This is also unique amongst the South American canids and all canids. These are organisms that these organisms live amongst tall grasslands, which is an explanation for why they have these long legs. They're largely solitary. They have the longest legs of all the canids, and believe it or not, nearly half of all of their calories come from eating a fruit. So they're mostly frugivorous. They're particularly dependent upon the wolf apple. So they've actually evolved this coevolution where they depend upon the apple for their diet.
Well, that's your
Now,
story, but
okay,
where's
yeah,
the actual evidence for this?
sure.
Go ahead.
So if we look at their overall genetics, what we can see is that when we look for what are called private alleles, are you familiar with what private alleles are?
A private allele? No.
Yes. Okay. So a private allele is, do you at least know what an allele is?
Yes.
Okay. For the audience, I'll explain what an allele is. So this is a variant of a gene that it could be just a single nucleotide polymorphism, or say an indel that is greater than, say, 1% or so of the total variation that you might find in a population. A private allele are those alleles for which are specifically found in a species, but not found in whatever species or other groups of species that you're comparing to. So the cool thing about this study is that they also look for private alleles amongst the different organisms, mostly focusing on bush dogs and Maine wolves, since they are sister species, right? These two organisms are more similar to each other than any of them are to any other species on the face of the planet, yet they have these clear, unique adaptations. The private alleles this is evidence that they have undergone specific evolution for these certain kinds of features. So for instance, the Maine wolf has a number of private alleles that are unique just to the Maine wolf that are not found within the bush dog. And there are private alleles that are found just within the bush dog that are not found in the Maine wolf. Some of these private alleles within the Maine wolf are regulators over limb bud growth. So limb growth is obviously something that's unique to the Maine wolf, in that they have these really long limbs, and the bush dog has these short, stubby limbs. There are other private alleles that are associated with the frugivory. So there are alleles that the Maine wolf has that allows for the digestion of fruit, that allows them to metabolize the fruit, the nutrients that they get from the fruit. This is the mutations that we see there are from previous existing genes, but these are now novel mutations that must have occurred from the divergence of the Maine wolf and the bush dog. And the evidence for the Maine wolf and the bush dog that they share a common ancestry is their genetic similarity. The genetic similarity can only be explained by the fact that they shared a common ancestor, just as we use genetic similarity for any kind of comparison when we're doing lineage analysis to determine phylogenetics, to see if organisms such as like myself and other people in Sweden, or myself and other people in other parts of the world, shared a common ancestor. And we can, of course, apply those same rubrics to organisms that are very similar to each other, yet if they show enormous differences, well, then we can also then look as that this is evidence that there can be selection for mutations that have occurred, and that those mutations, if they confer some sort of benefits, such as the ones that I'm showing as these private alleles, that then is the mechanism by which you can then get novelty to evolve through natural selection.
Okay. So this is a story that you're telling, and I
Sure.
have to tell you the issues that I have with it. First of all, they could very well have common ancestor. Okay, so
Mhm.
I'm not disputing that. You might be absolutely correct that they have a common ancestor. And there may be, like you said, the things that you've mentioned that are causing the lengthened limbs. These I would not have a problem with that being an adaptation.
Mhm.
Okay, it for the environment. And we've actually been able to view animals make big morphological changes even within their lifetime, okay, based on their environment. Okay, so that that ability, and I can just give one example very quickly. Lizards, meat eating lizards, that were isolated on an island. They were put on an island where they didn't have any meat to eat, and they actually their bodies produced a sickle valve to help them to digest plant eating diet. Okay. And so it was actually hailed as like this great feat of evolution. Okay. But
Mhm.
what they found is that when they put the lizards back on a meat eating diet, they lost the sickle valve. So what does that tell you? It's something that was already a latent ability that was present. And we've seen that a lot in various organisms, that we actually
Yeah,
do have the ability that's already present in the genome.
right.
It's a latent ability that can be tapped into when necessary.
Of
Okay,
course.
so this is
Yeah.
this right now, that could be what you're showing me, okay? And
Oh, that's
but we're
no, but
all
that's
but
not
we're
what this
also
is.
assuming
Right.
but we're also assuming so but we're also assuming common ancestry on that. And
Right.
like like we could, if we assume common ancestry, then what I'm saying is you're still not necessarily showing me an example of a novel feature developing through mutation and natural selection.
But
So
that's the only explanation that makes sense if these two organisms share common
why?
ancestry. And if well, how do you
If
explain
you said
these
if.
private alleles?
Mhm.
Yes, right. How do you
Yes.
explain these private alleles that are, 10% of the private alleles that are specific to the main wolf that are not found in any of the other canids that they looked at in this study? It's 6 other canid species that they looked at. They're specific to the main wolf. 10% of them are related to limb growth. And if they share a common ancestry with the bush dog, which, this is the only other species in the face of the planet for which they're more genetically similar to each other than they are to any other species, then these alleles are specific to the main wolf. They're not found in any other species. So they must have arisen via mutation. And then they were fixed in the population. So therefore it's then, and that fixation, that substitution, these are things that could have been naturally selected for, given the kind of environment that Maine wolves found them in. The ones that had slightly longer limbs were more likely to survive than the ones that didn't. They're found in these grasslands. And then so through the process of natural selection, you can get the evolution of novelty. For instance, the bush dog and their web feeding, which is it's obviously like a specific feature to the bush dog, because we don't see other species of canids that have this. They live in marshland, wetland environments where they have to do like a fair amount of swimming, and they have web feet that obviously we don't see in the Maine wolf. The Maine wolf does not have web feet, but bush dogs do. That's an evolution of a novel structure that is specific to the bush dog that's not found in any other canid. And then we have the very specific things that are found within the Maine wolf that's not found in any other canid, including the bush dog. That had
Well,
and we have the
mhm.
genetic evidence right in front of you. I mean, these are the private alleles for which we can already see are match this pattern of the unique features that these organisms have.
Well, now it could be, okay, it could be, like you're saying, there's a lot of
It's the
ifs,
most
okay?
parsimonious explanation.
Well,
Yes.
I don't know that it is,
Well,
but
what would be an
the
alternative? What
another
would you say?
explanation could
Yeah.
be, this is another example of you guys' phylogenetic trees being so messed up that maybe you should, uh,
Really?
give up on this idea. What
I
I
no, I'm interested in that. So you're suggesting that these authors messed up their phylogenetic
I
tree?
don't know. Look, you're bringing this to me fresh. I
Yeah.
haven't even looked. I
Okay.
have no. So I can only go by what
No
you've
problem.
proposed here.
Yeah.
Okay, but so
I encourage you
I
to look
don't
at it.
have the
This
detailed information to
this is a
go.
paper that was published in a very prestigious journal called the Proceedings of the National Academy of Sciences. Of course, that doesn't mean that it's absolutely true. Perhaps these authors completely screwed up their phylogenetics. I mean, there's a number of talented geneticists that are authors on this paper, but I don't know. I mean, maybe you're right.
Look,
Perhaps they completely screwed this up.
Dr. Thompson. Look,
Mhm.
I have no doubt that they're very talented geneticists,
Oh, sure,
but
but people make
there's
mistakes,
a
as you
main.
said. Yeah.
Well, actually, it's not about making mistakes. It's about the presupposition of evolution being true
Mhm.
and everything that's done being based on that presupposition. Now, if that is false, then you
Mhm.
can see how a lot of mistakes are being made, not because of their, an error in their,
Analysis, right. I think that you
it's
probably at least acknowledge that the genetic similarity that they are look at here, because they didn't look at just one bush dog. They had several examples of bush dog genomes, compared it to several examples of Maine wolves, and of course several examples of all the other dogs that they included in their analysis, right? They're not just simply looking at or the other wolf-like animals within their analysis. They're not just, they're not doing this willy-nilly. And the evidence is very, very clear that like bush dogs and Maine wolves, and they're not even the first one to publish this, right? Like we knew that bush dogs and Maine wolves, shared more in their genomes than prior to this paper. This paper just went into some of the additional mechanisms and a little bit more of a thorough analysis than some previous papers had done.
Can these two
Mhm.
interbreed?
No, they cannot.
Okay, so that might be one point against them being of a common ancestor.
Okay.
So and like I said, I don't know, and I haven't
Mhm.
looked into this.
Yeah.
But the main problem is a lot of people who try to come on here and share evidence
Mhm.
are their big evidence is shared genetic similarity.
Yeah.
Now, shared genetic similarity works equally well with the evolution story and the creation story.
Can you explain?
So, well, what's the problem with shared genetic, like how
Mhm.
does it, how do you like how can I explain? There's nothing to explain. God can
I don't
create genetic
understand.
similarity. God can create genetic similarity.
Okay.
So if
But what
we're
why
trying
would
to if we're
yeah,
comparing the
I
two,
hear that, but
yeah.
like why would say uh a coyote and a dog, why would they, or a coyote and a wolf, why would God make it so that they have similar genetic similarity um if they're just specially created and they don't share a common ancestor?
Well, I can't get in the mind of God.
Okay. But
Okay.
there's no reason to
So,
presuppose that. You said that that's an explanation that God could create these organisms to have similar genetics. Why? Why would it need to be that way?
it wouldn't need to be that way,
Sure. Yes,
but
right. I mean,
it
he
could
could,
easily be that way,
he or
right?
she or they could do it any kind of way that they
Yes,
want. Right. Yeah.
exactly.
They
So
but
it
what
could
we see
easily
is a
be
clear
that way,
pattern
right?
of, like, say, wolves and dogs have more similar genetics to each other than either do to, say, the coyote, and then the coyote and the dog and the wolf are more similar to each other than either are to the jackal. And we see this phylogenetic pattern. Now, in general, creationists typically accept that, oh, well, that's because they share a common ancestor, and that, of course, that's how that diverged. Now, I'm just kind of curious why you feel that that must mean that like God would be an explanation for that. That just doesn't make any sense to me.
Well, when we're comparing, okay, look,
Mhm.
I can't give you an explanation for why God did this, why God did that.
Mhm.
Okay, that's not, I don't have access to that information, right?
Yeah,
But if we're going to look and compare origin stories, right? And
sure.
we're trying to do this scientifically, right?
Right.
We have to, we're going by what we have access to, right? So we
Absolutely.
need to compare these origin stories, okay? And because genetic similarity can easily be that, it's equally possible on evolution and on creation. This
I don't
is
understand.
not a good, why don't you understand? What do you
Why
not
would
understand?
I don't understand why that organisms that, say, look similar should necessarily have similar genetics if they are specially created. If you have a raccoon and a dog kind, or a bear, why are they all similar to each other genetically than any of them are to, say, like a lion or a tiger? Or even if you're going to presuppose that, say, the Maine wolf and a gray wolf are separate ancestry, why are they similar to each other if they're specially created? It doesn't make any sense.
Why doesn't it make sense?
Why would a designer do it that way?
Well, that's a religious question,
Is
not
it?
a scientific one.
Okay.
Okay.
Interesting. Yes, that does mean, I suppose, that creationism is not science.
No, it's look,
I mean,
it
we're trying to
I'm
come
not
up
saying,
with a mechanism on our side, right? We have natural selection, we have mutation, we've got mechanisms that we can discuss. The problem with the creationist side is that they don't have any mechanism. They can't discuss how did it come about
and
or
that's
even
true.
why.
That's
Right.
fair. That
Yeah.
is fair. That's
And
fair.
it's a
Right.
huge disparate gulf between the two.
And so, but suppose it is true that God created.
Okay.
Okay.
Yes. But why
Now,
would they be similar? I
how
don't
would
understand.
you figure that
Yeah.
out? How would you figure that out? If that's really what's true,
Yeah.
how would you figure that out?
I mean, I'll be frank, like I'm more interested in the multiple designer theory. I actually think that there's better evidence for that than there
Okay.
is that there was like a single designer. Um, and that's only because when you look at nature, it's pretty obvious that everything, if we presuppose that all these things are designed, nature is rooted in it's bloody in tooth and claw, that organisms basically are eating other organisms day and night, and they're all there to eat and digest each other and kill each other. And to me, it almost seems as if like it would be a sick joke for one designer to design all these things to kill each other. It makes more sense that there might be like a snake designer designing snakes. He's on the snake team and he wants them to like go out and kill other organisms. But of course, then there are other kinds of designers that might be, say, the mongoose designer who's designing mongooses to then fight against the snakes. I mean, it makes more sense to me that that might be the
Interesting
case.
idea.
Sure. Yeah, it's the multiple designer
Hey,
theory.
that's truly an interesting idea. And I
Sure.
will tell you, from my perspective,
Mhm.
if you embrace that, like the idea of a designer, even this
Mhm.
idea of many designers
Yes.
is much more scientifically palatable than the origin story that begins with natural processes.
Really? But there's no mechanism
Because
for that.
I think
Like I don't actually see any evidence that
no.
snakes are designed. Or I don't see any evidence that like, because like when I go and I look for design in my life, I there are a few things that I can look for. For instance, I've got a phone and it says that it's made in Korea because it's a Korean phone. It's a Samsung phone. That's some evidence that like there is a designer and that it was designed. And then I can go to that factory in Korea where it is being put together and assembled. And then I don't even necessarily have to go to the factory. I can look at it and realize, okay, well, here are things that are screws and things that's how this works, that it has to be assembled by a human being or some sort of robot. There's a mechanism that I can describe by which it actually occurred. But I don't hear any mechanism for how, say, the snake designer designed the snakes, or how the
Yeah.
mongoose designer designed the mongooses, or the Maine wolf designer designed the Maine wolf, and the bush dog designer designed the bush dog. There's
And
no mechanism,
we don't have
right?
access to that. Okay, that's
But why
something I
not?
fully admit.
Yeah, like
Well,
shouldn't there be like a snake designing facility someplace? Like this must have happened on Earth at some point.
I mean,
Just like there's a
you're
factory.
welcome to
I can
go
go to a
and look for
factory and
that.
see the
Yeah,
designers doing their designing.
right. But, so then are you saying that we should accept a mechanism, no matter how ridiculous it is, no matter how much it
Oh no.
doesn't work,
Mm-mm.
no matter how insufficient it is for
Hmm.
explaining, we should accept it an explanation because it has a mechanism
I
over
think
yeah.
that no, you shouldn't accept just any mechanism if there's contrary evidence that disproves the mechanism
Okay.
in a substantial way. Of course,
Yeah.
that just might mean that the mechanism needs to be revised. Now, I think that mutation, variation existing in a population, and that natural selection are actually really excellent ways of explaining the evolution of novelty, such as the example that I gave. The bush dog and the Maine wolf are fantastic examples of organisms that clearly they share a common ancestor. I think that you agree on that, or at least most creationists certainly agree. If you don't, fine, you're an exception. You're now creationist number two that would disagree that those two organisms
No,
share
I
a common
haven't agreed
ancestor.
or disagreed. I
Sure,
don't
that's
know.
fine.
I
That's
haven't
fine.
looked
That's fine.
into it. Okay.
I've only met one creationist that disagreed that they share a common ancestor, and he also happened to believe in gnomes and elves. So there's that. So he believed that all the different breeds of dogs also had their own special creator.
Oh, are you talking about Bubblegum Gun?
Oh yes, yes. I'm talking about Bubblegum Gun. Dude is
Shout
whacked.
out to Bubblegum Gun.
He's crazier than a rat in a tin house. Yep. So Yes. So, but just about every other creationist, of course, accepts that all the wolf kinds share a common ancestor. That has to include the bush dog and the Maine wolf, given
And
that there are these
what is
very
their
specific.
explanation
Mhm.
for then what how do they respond to the evidence that you presented based on their understanding of them having common
I mean, in the
ancestry?
past, they kind of just shrugged their shoulders and they kind of said the same things that you are, like, well, I don't have a good explanation for this, or it could
Wait
be
a
that, it could
minute,
be
I
this.
gave
Uh-huh.
you an explanation.
Oh no, you didn't.
What was my I said this is
For
a possible explanation. Wait,
yes,
what was
but
my possible explanation?
your explanation for the origin of bush dog and Maine wolf is that a creator could have made them that way,
Wait. No,
right?
okay. Yes, that's one. I said that's one possibility.
Right.
But another possibility, I said if they have a common ancestor,
Yes.
one explanation for this variation is what is already present in genomes
Ah,
to adapt to help.
gotcha.
And
Okay.
we've seen major
Right.
morphological changes even within the lifetime of an organism. But
Yes.
that did not happen through mutations over millions of years collecting together and coordinating and do this. When we have
Mhm.
observed it, we've observed it where this is a change that can happen right away because of the
Sure.
information that's already present in the genome. So
Yes.
I submitted that as a possible explanation for the variation that you see between
E-
those animals.
Except that the variation that we see in those animals completely corresponds to the private alleles, and that's why I brought up the private alleles. The private alleles are specific genetic signatures that are found in one species. They're not found in the other species.
And
These
for you,
Mhm.
that means it's a mutation. But for
Absolutely.
me,
Yes.
that doesn't necessarily mean that.
What do you think
Okay.
that what is then the origin of that variation?
Well,
If they share a common ancestor,
yeah, if they share a common
where
ancestor,
did that variation arise?
I would say, okay, another possibility is within what the gene regulatory network can choose to promote. They can make regulatory network can make duplicates of genes and switch them up, change them around. So that may be an explanation.
But these are okay. No,
Why?
just say flat out no, because you're talking about that this is gene duplication. Okay, so this is not gene duplication. These are alleles, right? So there's a specific mutation. They know what the mutation is. They can look to see
Right.
what's
I
different
know.
genetically. Yes, and it's not that these genes have been duplicated. It's that these are either SNPs or indels. They're very small changes. I think nearly all of them are just SNPs, so single nucleotide polymorphisms that are specific to one species but are not found in the other species. So there's no gene duplication occurring whatsoever. And
Okay.
now it certainly is the case that it's likely that like this SNP may be affecting the expression of other genes. That's just the nature of all gene networks. Like gene networks are highly promiscuous, right? The products that are made by genes often will interact with lots of other products or affect the expression of other genes. And without a doubt, I'm sure that there probably are some of these SNPs that result in changes in expression of other things. That's just the nature of development of organisms. Like it's a very mixed, messy process of lots of like promiscuity. I mean, I use that term specifically to say that like things like to bind and then affect each other in many ways, and in very messy ways, honestly. Yet that one small change can result then in a substantial phenotypic effect, such as like the lengthening of a limb. And as I said, 10% of the private alleles that they found that were specific to the Maine wolf are also known to be regulators of limb length.
Okay.
And that if the bush dog and the Maine wolf share a common ancestor, those private alleles did not exist in the common ancestor, because then they would also, you'd see them at least in the bush dogs. Of course, in this analysis, they didn't just compare it to bush dogs and Maine wolf. They also compared it to 4 other species of canids. And so therefore, when I say private alleles, they're private alleles across all like 6 species. So it's only found in one and not in the other 5. And again, because, of course, at least amongst scientists, biologists, we accept that all the dog like animals share a common ancestor, and most creationists accept that too. if there's an allele that's specific in one species, it had to have origin by mutation.
Okay, and so you're saying so how many mutations are you saying are responsible for making the tall legs?
Well, the number of private alleles that they found in the Maine wolf is something. It's more than 100. So they found more than 100 of them, and they were about. And as I said, it was about 10%. So it was on the order of about 10 uh, specific alleles that seem to be related to limb length that are found just in the Maine wolf that are not found in any other dog species, including its sister species, the bush dog.
Okay.
Yeah. And that this must have arisen via mutation if they share a common ancestor. I mean, there isn't any other explanation. What would be the other explanation?
Well, if you have that detailed article, I would love to read it,
Oh,
and then
sure.
I will like look into it, and if that seems to be a good example of
Absolutely.
mutations
Yeah.
providing a novel thing, then I will post it on my list of
Mhm.
evidence that people have brought for evolution.
Great. I appreciate that. I mean, it's a really excellent paper. I think that I encourage everyone to look at it. I mean, because this is the thing, like creationists, evolutionists, we all agree, most of us, not everybody, that the dogs share a common ancestor, and that's just a great starting point to have this conversation. So if there was just one male dog and one female dog that came off the ark 4,000 years ago, then if we have 34 different species of wolf-like animals, how do we explain the origin of those species? And that's where I think that we can put a lot of effort to try to really come up with a simple mechanism. Because you're right. Like that clearly, if there's just two organisms that came off the ark, there were dog-like organisms. They resulted in these 34 different species in just 4,000 years. What is then the mechanism by which that occurred? Is it consistent with the genetic evidence that we see? At the very least, we both, or at least most creationists and myself would agree that there is a shared common ancestry for those organisms. And so that's why I like to start with this example, because we're not talking about like 34 just like dog looking like things. There's extraordinary examples of novel structures and novel phenotypes within this group, which is just fantastic. And I just think that it's a great starting point for the conversation. And that maybe the explanation is that there was just a dog designer, right? Like and this is just an example of the multiple designer theory. Or maybe there are multiple dog designers. Maybe there was a South American dog designer, right? And that there was a wolf designer and a fox designer. Or maybe there is just the main wolf designer, and that's why they're competing with, I don't know.
Yeah, well, like I said, I think you would be on a better basis scientifically if you
Mhm.
fully embraced that view of
Oh, sure.
multiple designers
Oh,
rather
I'm
than
totally open. I would
you
just
are?
love, absolutely. I'm
Okay,
absolutely
so
open to the
you're
idea
not
that
committed
there's
to
design.
natural
Yeah.
processes. Are you
I
like
mean,
do
I
you
still think that design is a natural process. Like when humans design a phone, that's a natural process.
okay.
Do you not agree?
How well, I don't it would depend on how we define natural, right?
Really?
Like how do you define natural? What I the way that I'm thinking of natural is
Yeah.
without intelligent intervention.
Oh, I see what you
Okay?
mean. Okay.
You see what
Right.
I'm saying? Like
As opposed to
naturalism,
supernatural, right? Yes. So,
right?
yeah. I mean, obviously, that would be if there was some sort of, say, an alien that came to Earth, and or groups of aliens came to Earth, and they were the ones that were the multiple designers designing the snakes and the mongooses and the dogs. I mean, that's definitely one explanation, and that would be intelligence, of course, doing that, but that's still a fully natural process, is what I'm saying.
Okay, well, so that's just us having a different word usage, right?
Oh,
So,
sure, right,
you
as
know,
opposed to supernatural, right. I don't accept supernatural processes.
But
Yes.
I'm saying I'm using natural different in that I would
Yes.
call that intelligent intervention. Like, I would
Sure.
say that's not a
That's fair.
natural process. I would
Sure.
say, like,
I see what
when
you mean.
I'm
Yes.
saying without, like, an intelligence intervening, whether,
Exactly. Right.
whether
But
it's an
you
intelligence that we can
right.
see, taste, and, or taste.
But you agree that that as scientists, we have to use natural processes to explain phenomena that we see in the world, and then we can't depend upon supernatural explanations.
Well, I think we should search for the truest explanation, and wherever the evidence leads us, that's where we should
Mhm.
go. And I think that's actually one of the main problems right now. And one of the problems that evolution has been able to stick around for so long is because if you rule out anything that is not by that doesn't go according to methodological naturalism, if you rule out other explanations, you're crippling yourself, you're forcing yourself to you're basically
Sure.
like ruling out possible good explanations
Sure.
for our existence. And so
Totally
I
agree.
think that's
Yes.
what has happened is that
Mhm.
we've shackled
Mm.
ourselves, right? And I'm
Mm.
I'm saying I haven't, but many people have shackled themselves to certain types of explanations, and they're unwilling to examine the full scope.
Well, I strongly disagree with that. I just think that when you look at the evidence of just straight up phylogenetics alone, that we know what the substitution rate is in these organisms, that when we compare the genomes of these organisms, if we all accept that they share a common ancestor, we're talking about, say, the canids, that
Yeah.
the idea that they arose from a male and a female off the ark 4,000 years ago, that's obviously something we can completely rule out. That the last common ancestor for the wolf kind had to have been around 9 million years ago. There's no other way to explain that. So at the very
Well,
least.
and
Now
see,
that
I think
maybe
there's
it's
major problem with that, but I
sure.
mean, that would
Oh, okay.
we'd be opening up a huge can of worms. But I just
Yeah.
will make this point is that, if evolution were true, we
Mhm.
should see a nice, neat phylogenetic tree of common ancestry, right? We should be able to group organisms together, and it should all match with the morphology and the genetics and the proteins that are in each system, and all of this should match. But instead, every part of the tree that I've looked at has tons of contradictions, multiple
Really?
contradictions. Yes, it doesn't match up with the proteins, it doesn't match up with the even the morphology, and it doesn't match up with the genetics, and it
So I
leads to
think
some really
morphology,
ridiculous places.
obviously, I actually would take an exception to that because I don't think that you can depend utterly just comparing on morphology, right? Because morphology, obviously, you can have lineages where there's been substantial selection occurring that say if there's a common ancestor that's split into two different populations, one goes to the wetlands, one goes to the to grasslands, that you can see extraordinary divergence in overall morphology over a relatively short period of time, which is exactly what we see in the bush dog and the Maine wolf, right? They're extraordinarily different in overall morphology, yet they're more similar to each other than either of them are to any other organism on the face of the planet, which suggests that they do share a common ancestor.
Yeah, or
Right. So we
it
can't just
could
depend upon
be
morphology, and most biologists would say that.
well, and that's the thing is, wouldn't you agree that
Mhm.
it might be expected that the genetics and the morphology would match up and they wouldn't be contradicting each other?
I mean, in general, there's a lot of that, but I think that and we can find lots of examples where there's divergence, which is fully consistent with populations being split and going into very different environments. If they're under different selection pressures, they're going to look different. An animal that, some sort of wolf-like ancestor that made its way into the wetlands is going to look very different than a wolf-like ancestor that made its way into grasslands.
Okay.
Under
Well,
the process of natural selection, which clearly we see with the Maine wolf and the bush dog.
but then you have these uh, all over examples of things that are basically evolving multiple
Mhm.
times the exact same feature to try to
Sure.
fit it in on the tree. You have, the same feature evolving many times,
Yes,
which
sure.
is
That's one
very strange.
explanation.
It's
Mhm.
already really strange
Yeah.
that you get the thing once. To get
Not
these
really.
complex mechanisms to come together once is
Yeah.
already incredibly difficult.
Why is it
Okay.
difficult though?
It's difficult because you have uh there's no mind involved, right?
Right.
These are supposed to be random mutations,
Right.
right, that are
Yes.
occurring,
Mhm.
and then these mutations have to coordinate because it takes a lot to build an organ or a system. So you have to get, you know, this great serendipity of these mutations that just happen to work together and provide a great function.
But
And then,
Rebecca,
so
I'm sorry, but there's no example of like an organ that is that is utterly dependent upon a suite of genes that only contributes to the function of that organism or organ. That it just doesn't work that way. Like there's not a single part of your body where you have genes that are utterly dependent upon uh, uh, that organ is utterly dependent upon the function of just those genes, and those genes contribute nothing to any other part of the body. The biology is a lot messier than that, and so there isn't the what you just proposed there is a complete straw man. That there isn't that isn't even an example of how evolution could possibly come about, because obviously what you're trying to imply there is the concept of irreducible complexity, that if an organ, we realize that it's complex, you can look at all the genes that are expressed, say, in the liver, and therefore all those, like, nearly 2,000 some genes that are expressed in the liver, they must have all come about in that way in order to be expressed in the liver to allow for the liver to function the way that it does. But all of those other genes are expressed to various degrees and are involved in different functions within the other parts of the organism. Like there are many of the liver genes that are also expressed in the brain, which I focus on. I have to deal with the fact that the liver produces some things and that it's also produced in the brain, even though it's the same protein.
right. And actually, this could get into a very deep conversation, which I would love to have sometime. But there is
Sure.
somebody who's been waiting backstage for quite a while. Grayson has been
Are
waiting
you talking about
backstage.
Grayson? You're
Yes,
kicking me
Grayson.
off for him? I'm just kidding.
Look,
No,
I
that's
but
fine.
but but
I'm
I
only
would love
joking.
to I would love to have a conversation with you about your area of specialty. Let's
Sure.
talk about the
That would be
brain.
great. Yes.
And
Yeah, I would love
so
that.
have you done much work on brain evolution?
Believe it or not, I haven't done as much as you might think, but I'm happy to read up on it. And but there's a lot that we could talk about, and I actually have some really great examples of brain evolution that I would love to talk about with you. We can do that
I
next
would
time.
love that.
Yeah,
Let's
Grayson
do
says no
that.
rush at all, but I'm just playing. I have other stuff I got to do anyway. I'll let Grayson jump on, and I give my best to Grayson. He's a buddy of mine, and obviously, if I'm going to be replaced with anyone, I would pick him. So,
Thank you for coming on,
yeah,
Dr.
sure. No, actually, I
Thompson.
really
Come
enjoyed this
again, please.
conversation. I actually have seen several of your videos. I appreciate um your what how do I want to put it? Uh Probicity, the your willingness to challenge, and I enjoy that a lot. So yeah, and I think that you do
Cool.
it in a very effective way. So
Well, you made my night when you showed up. So I was really happy. I was really happy to have this conversation. And
all right.
I will look into the thing that you brought up about the wool. I want to read that paper.
Oh, I will put it in the chat. I will
Okay,
put that
perfect.
link in the chat, and then
Yeah, you
but
might
go
have to,
ahead
but I
and you
don't
can let
think
Grayson know.
YouTube will let you put it in the regular
No, I
chat. You
won't put it
might
in the
have to put
chat
it in the
there. I'll put
private
it
chat.
in StreamYard.
Okay.
Yes, or
Okay.
yeah, we're on StreamYard, right? Yes. Okay.
Perfect. Okay. Have a good night.
Sure.
Thanks.
Yes. Bye-bye.
Hey, Grayson.
Hey,
Good to
Rebecca, long
see
time no
you.
see.
Yeah.
Yeah, that was
You
an
haven't
interesting.
been on recently. I've been waiting for you.
Well, yeah, I've been a little bit busy, but that was a really interesting conversation with Dr. Chris there. Shout out Dr. Chris, he's awesome.
Cool.
I also overheard your conversation with Erika the other day.
Yeah.
That was very interesting. I was curious, first of all, before we get into any of the evidence or whatever, like, have you been thinking about any of the stuff that Erika brought up after you talked with her,
I
or
think
how does that
Erica,
gelled with you in the weeks since then?
yeah, I think Erica has by far brought the best evidence for evolution. Okay.
Okay.
Now I say that and I don't want to diminish it, but for me, it is not good evidence for evolution. Okay, but it is. I counted it as evidence for evolution, and I think that it's strong in that there was a prediction made about the types of creatures that we would find if
Mhm.
human and apes shared a common ancestor, and we found some features that seem to fit in with what we would expect. So I
Mhm.
count that as a, like, prediction, evolutionary prediction fulfilled, and so I count that as evidence for evolution. For me, that it doesn't actually answer my concerns about evolution. It doesn't answer the problems with evolution. So, and so it doesn't provide what I would be looking for to demonstrate that evolution is a good scientific theory.
Okay, but and so there's no amount of successful predictions for fossil anatomy that would ever amount to good evidence, because I
No, I
believe in
think
that conversation
there could be an amount. Yeah,
because in that
I won't
conversation
say there's a limit. I'm not gonna, no, I'm not
okay.
agreeing with that. Yeah.
So because we had already established that, they predicted the anatomy of Tiktaalik and the location where they would find it. They did the same for Archaeopteryx. They've done it for synapsids. They've done it for Australopithecus, Ardipithecus, Sahelanthropus, like in the human evolution line. I mean, it's just like it's not just limited to human evolution or Tiktaalik. It's like pretty ubiquitous that we make predictions based on evolution and find the fossils that match those predictions in anatomy and in the placement in the rock strata. So it's like at a certain point, it's like how many successful predictions does it need to amount to good evidence, right? Because the main thing that I wanted to talk to you tonight is involved with this because it was the ordering of the fossil record, which I would say is very, very good and sufficiently convincing evidence for evolution. So
Hmm.
that I would just be curious about your thoughts on the ordering that we see in the fossil record.
Yeah, well, I actually think the fossil record is not evolution's friend. Okay. Now, I will also admit the fossil record is not young Earth creation's friend. Okay. So, like, the fossil record isn't what I want it to be for young Earth creation. Okay. But it's also not what it should be for evolution. In fact, I would say you have a lot more it you have a lot bigger problems with the evolutionary story and the way the fossil record looks. And here's why.
Wait, can I make one claim
Sure.
before you explain why it's a
Yeah.
problem? Because I'm very interested in why you think it's a problem for evolution. But I would
Yeah.
actually say that evolution is the only physically possible explanation for the order of the fossil record that we see. Like, and maybe you have another idea, maybe you don't, and it's just one of those things where you say, I don't know how God did it or why he did it this way. But like, when we look at the ordering that we see in the fossil record, there is no way to get that to that order with a physically possible mechanism that does not violate the laws of physics other than evolution. I'm not aware of any. I've heard all of the creationists like ecological zonation type arguments or whatever they say, but I'm just curious about how when you look at the ordering of these fossils, it just seems to just scream this could literally only be due to evolution. I want to understand your perspective for how it could be otherwise, because I can't even wrap my head around how you could see that and not make that conclusion.
Yeah. Well, here's some of the problems then. So, one is we have the sudden appearance of forms. Okay. And that's not what we expect for millions of years of evolution. Okay. And I can start naming some. I don't want to, and I will do that if you want. So, we have sudden appearance of forms, and we have sudden appearance of complex forms even at the lowest levels, right? So, in the Cambrian, we have,
But those aren't
and
the
I
lowest
know
levels,
that,
right?
well, okay, you can say Ediacaran or, whatever. But what
Sure.
I'm saying
Yeah.
is, like, like you don't have a progression getting to the Cambrian, right? Like,
I definitely see a progression getting to the Cambrian. There's
can you give me an
Proarticulata.
example?
Like, yeah, okay. Have you ever heard of Spragina?
No.
Okay, I will just pull up a
Pull it
picture of
up.
it. It's a type of Proarticulata. And here we go. And then I'll just share my screen. So, because I hear all the time that there's no precursors, but then like you say like a trilobite, for example, just appears out of nowhere. But this is in the layer below. It looks sort of like a trilobite, only way simpler. There's no eyes, there's no like feet. It's got a different type of symmetry. Like it's just a
Okay,
much
I have
more
seen this.
simple form that really looks a lot like a trilobite to your eye. I mean, we do see precursors for these things. It's not like they
What do
just
you
appear out of
see
nowhere.
as simple on this?
Like I've listed
You
the things, like
no
there's no
eyes?
eyeballs. Like this is a very simple body plan of just like a little zigzag symmetry. Like you could form this using very simple rules. For example, like you say that like you have one gradient that establishes the head and the tail, and then you have these branching that goes right left branching, and then boom, that explains his whole body plan. I mean, it's fairly simple in terms of the kind of genetic algorithms that would be involved, or like the biochemical algorithms, I guess, evolved in like how you build this form.
Where do you see the information coming from for building this form?
From like the interaction between the genes and the biochemistry, like in the environment. But are you just getting to the fact that like that you don't understand how mutations could give rise to like these like novel structures or whatever that you were talking about with Chris? Or
Well, okay, look, I don't know where I'm going with this,
okay,
but look, for me, when I look at this, this doesn't look like a more simple organism than a trilobite, but it's very hard to tell because all we have is this basic imprint,
so I will
right?
say
Mhm.
that in consensus, this is not even a direct ancestor of the trilobite because they are so radically different. According to like the scientists that make their entire careers studying the anatomy of arthropods in the Cambrian and Ediacaran, this would be so completely different to a trilobite that they would not even classify it as closely related. But I'm just telling you that this is just a clear precursor in the fossil record that looks like a trilobite millions of years before trilobites evolved. Like it's not like they just popped out of nowhere and there was nothing that looked like a trilobite beforehand.
But you're saying they say it's not an ancestor
Yes,
or
because this has a completely different body symmetry. A trilobite is left-right
okay.
symmetric, and this is not.
So
This,
then where do you see the ancestors of the trilobites?
well, it's involved in like basically the ancestors of the arthropods in general, which Proarticulata, like what this belongs to, could be in relationship to that. But there's also some really early like proto arthropods that look like they have a body plan that's more similar to a trilobite's, where they have bilateral symmetry and they have 3 segments to their body like a trilobite does, and that creature is Eulingia, and it looks more kind of like a worm, but it does have features in common with trilobites. But I think that this is just a visually clear example of a precursor, like refuting your point that these things just appeared out of nowhere with no precursors. And again, though, due to the paucity of the fossil record and how difficult it is to form fossils, I don't think that this is a problem with evolution at all. I don't see any problem for evolution in like the fossil record, other than just it's really hard to find fossils and we don't have all the different types of fossils. But I mean, in terms of like how we think about evolutionary change happening, you go to like these plateaus of stability, and then when the environment shifts, then you have to have like a rapid evolution to match that new fitness peak. So that's our understanding about how evolution works, and that's not in contradiction in the fossil record. So I don't see your first point as being problematic at all.
Well, I mean, what do you like? I even Darwin disagreed with you.
Well,
Okay.
Darwin was wrong about a lot of things because he didn't understand genetics.
Right.
Like Darwin is not like, it's not like a Bible scripture where you quote
No,
Darwin
I
and he's the end all be
obviously
all.
I realize that, but what I'm saying is the Cambrian explosion, okay, is a known problem in evolution.
It's not.
It it is, and
It's
I'm
really not.
saying
I'm sorry.
I'm just making the point that it was known in Darwin's time. Darwin was aware of it and he was concerned about it, and it has continued to be cause for concern.
It really hasn't. I'll explain why. Because during Darwin's time, they were not aware of the Ediacaran period at all until the 1950s. They didn't know about the Ediacaran period, and now only since the 2000s have we really started to find lots of specimens from the Ediacaran period. So, like, it's just out of date what you're saying. Like, it has been superseded by our findings
Okay.
from the Ediacaran period. Like the example that I gave you before of the proto-arthropod Eulingia, that was only discovered like 5 years ago.
And I'm glad we're still making those discoveries, okay? But the fossil record has many sudden appearances of forms, and it goes way beyond just the Cambrian, okay? It has the sudden appearance of many forms, and we are severely lacking in transitional fossils. If this story is true, there should be many more transitions than of the animals that we see. And I can start naming off some that we don't
Okay.
have transitions for.
Okay.
Seals. We have 5,000 seal fossils
Mhm.
and no seal predecessors. Why? Why would
Well,
we have
I haven't looked
that
into
many?
seals yet, but
Yeah,
I do have a
and
video.
that's what I mean. I'm not trying to put
No,
you on the
but this
spot.
is
You don't have to
interesting.
be an expert.
But this is
right?
what I want these points to be brought up so that I can go and look up this question in the future,
Yes.
because I have an entire video highlighting about a dozen or so transition fossils, and like I could have picked hundreds to go through of examples. Because for every example that you could provide, I could provide a counter transitionary fossil. Like you could say seals, I could say whales, and we could go tit for tat with this, right? But
Well,
my point
whales.
my point.
Whales would be a fun conversation, because the whale story is really kind of hilarious, but the whale evolution story, that is. So, but we have like 1,000 whale fossils, I believe. I have to look up the number, but we have quite a lot of whale fossils, right? And then
Mhm.
we have a couple of creatures that were land dwelling creatures that we say were, basically whale predecessors, and on, like, I would say, ridiculous evidence.
I
So,
don't know what you find to be hilarious or ridiculous about that evidence. It just sort of seems like that's like an emotion you're experiencing with the evidence, but I don't know why that would be a gauge for its truth or not. I mean,
okay.
there were like a lot
Well,
of things with like quantum mechanics that people would think were ridiculous, but they were true, and it just ended up that human intuition was what was wrong. So I don't know why you would trust your intuition over the arguments for the evidence in this case. It's not like we just have, oh, these land animals that like have similar anatomy to whales, and then poof, we just have whales. It's like there are in-betweens that are semi-aquatic and not fully marine and not fully terrestrial, and they're in between and they have transitional anatomy as well.
well, maybe we can look at that sometime, because my understanding is that, one of the fossils that's supposed to be the transition to whale did not have a tail, a fluke, but it was assigned a fluke. Okay.
I'm
So,
not sure what example that
okay,
you're
yeah,
bringing up.
we'll have to look it up, because I'm not prepared to give to go, like, I'm not prepared with the information tonight. But I
The
mean,
interesting thing, right? Are you aware like why they group like the inner ear bone, right? Have you heard of that being similar for all these groups, and that no other group of animal on Earth today has that type of inner ear bone, and like except for whales and these extinct semi-marine and terrestrial groups of animals that have that same inner ear, when
right.
no other animals today have it.
And if you have no other option for origin story except evolution, I can see why that would be evidence to you.
I
Okay,
do
but I
think
have another option. See, I don't believe the evolution story. I think God created. So it's no problem for me that God put some kind of ear bone in, some kind of similar bone in two different creatures.
See, I actually don't think that there is another like physically possible option because of the ordering of the fossil record, which again is like my main point here of like specifically we've got, you know, mammals towards the upper layers, we've got, you know, dinosaurs over here, we've got like only aquatic animals, and then we've got single cells only at the bottom, because again it goes beyond the ediacarate. We've got a billion years of layers of just single celled organisms. So it's like and I know you disagree with the timeline, but just like a thick layer of just single cells. So it's like I look at the overall pattern, right? It's not like just hyper focusing in on just this one seal evolution or whatever, where like, yes, like everybody agrees that the fossil record has gaps, because it's really, really hard to have the, like really rare to get the conditions to have a fossil to form. But when you look at the overall order of it, like, how is that not just 100% definitive? This can only be from evolution. Like, there is no other physical mechanism that could happen. Like, unless you want to say that God created those fossils in that order, and then it's just like, why? Like, why would he do that? It seems like he would be tricking us, right?
Well, do you mean that God, are you saying that the organisms didn't, like,
Yeah,
under that
the
scenario?
only explanation would be that the organisms were never alive and that they were created as fossils in that order. Or, like, if they were alive, then God would have to have like done a miracle to like put them in this specific order that would make us think that they evolved. Like, it would seem like a deception.
Well, I mean, look, I think actually, like I said, I do think that I think I can offer a okay explanation for why it's like why the
Yeah.
layers are like they are. I'm not saying it's not gonna be, I won't call it good. Okay.
Okay,
And I
sure.
won't call it, I won't say there's not problems with it.
But
Okay.
you say it's a better explanation than evolution?
Uh I would say the fossil record is problematic for every possible scenario, and evolution is included in that. It's very problematic for evolution. So I don't know how to weigh it and say which one is better,
Okay.
but I would say, like, I don't think evolution is your friend as far as, I mean, the fossil record is not your friend with evolution. And so let me give a couple more examples of that, because I know you're skeptical and all I said was seals, right? But
Well, you
think of,
pointed to like very specific lineages that have gaps in the fossil record. But like I'm talking about the overall, like zoomed out order that things appear in the fossil record. And I don't see that being like that's like far from being problematic for evolution. That is just like, to me, like just definitive evidence that it's like this has to be evolution. There's no other way, there's no other explanation for this. So that's what I'm
so
talking about.
for
Just
you,
the
it's not
overall.
a problem, the sudden appearance of wings of all types, like sudden appearance, like no development of wings at all, like sudden appearance of insect wings, sudden appearance of bird wings, sudden appearance of mammal wings, sudden, because even Archaeopteryx, full feathers, full wings, right?
Mhm.
No development of feathers, we have full feathers, full wings, and then we have mammal wings, we have
Mhm.
we have no development of bats, we have complete bats, we have 1,000 bat fossils, no predecessor to bats, no predecessors to dinosaurs, we have so many
Well, we have a
dinosaur
lot of
bones.
predecessors to dinosaurs.
Well, I mean, we don't have any, we can't point and say this is how the dinosaurs evolved,
I
right? We
think you
have the
can.
sudden appearance of dinosaurs.
I
Okay.
did cover it in my video on transitional fossils, the early transitionals for
I'm
dinosaurs,
gonna
like
watch
Eoraptor.
your video. I'm gonna watch your video.
Okay.
Okay. I'm gonna watch your video. Okay. But we have the sudden appearance of fish. We've got we don't I don't
I don't
even know
think we have
how
the
many
sudden
fish
appearance of
fossils
fish
we have.
either.
Well, every person who's tried to bring to me a fish predecessor has brought me a fish. Okay.
Well, like some of the earliest fishes don't even have like developed heads. Like, I mean, we see like a very progressive evolution of fishes in the fossil record. Like, like where you could see like the early forms of gills, that like the early forms of development for jaws. Like I would say that
See,
fish is
this is
actually a very clear transition.
to me, this is a actually good imagination at work. Okay. So like I don't see what you're seeing. And like trying to explain where the vertebrate column came from. We've got, you know, a million or more in probably, I don't even know the numbers, okay, but a lot of
Mhm.
invertebrates.
Yeah,
And
we've
then
got a
we
great
have
transition
the
for that as well.
sudden appearance of the vertebrate column.
No, it's not
Where is
sudden.
the
It's
transition?
preceded by a notochord, which is not a spinal column or anything. And we see that again, like Haikuichthyes, a bunch of the very early like Cambrian like proto fishes. Like this is like I think that some of the things that you're saying are like just like maybe you are not aware of the examples.
And that's possible. Look,
Some of the things that you're saying, I think that actually just this year there was a recent breakthrough find in early bat evolution transitions, but like still I would agree with your more broader point with like the evolution of wings, although I think that like there are like the earliest wings that we find are simpler than later wings that we find, but I do think that like there are certain transitions that happen very quickly where you don't have millions of years of like a plateau form where like for example like you have a lot of opportunities for something to fossilize if it exists in that form for millions and millions of years, but if the transition happens within only like 1 million years or 2 million years, then you have a lot less example like possibilities to form these fossils. And like I think some of the earliest examples of flight is like wings are more so for gliding and like not even for like powered flight. So some of these I do think have transitional like intermediary aspects to them, but some of them like the transition probably happened very quickly. Like once you start forming wings, like the selection pressures would like clearly favor continual development of that. So it makes sense that some of these things would evolve faster.
Okay, now, so I'm just going to tell you up front. Usually, when I do these streams, I have to have people bring specific things and like one specific, like I can't go and do homework on
Yeah.
everything that you mentioned
My,
because that will like you've got to bring it one by one and I'll
great.
count it. Or, you know what I mean?
My
Because like, yeah,
my one piece of evidence, like I'm saying,
yes.
I'm not zooming in on this specific lineage and that specific lineage in the fossil record. I'm talking about the overall. When you take a step back and you just look at, well, what types of organisms are we found up at the top layers, and what types do we find in the middle, and what types do we find at the bottom? When we just look at the overall, like bird's eye view of the
Okay.
whole fossil order, the only physically possible explanation for that I am aware of is evolution. Like every single other potential explanation is impossible unless you evoke some sort of miracle.
Okay, well then maybe I should offer you my other explanation, which and actually there will probably be some young earth creationists that are mad at me for saying that this is just an okay explanation because I know there look there's a lot of people creationists who have a lot better knowledge of the fossil record than I do and might think that I'm not giving credit for our view, okay? But to me it does make sense in general that we would find the sea creatures at the lowest, because my view is that there was a worldwide flood and that many creatures were buried in that flood and sediments moving around the whole earth. And so it makes sense that what was on the bottom of the ocean was covered in sediments first. And so that's why we have a lot of marine fossils at the bottom. And then it makes sense that at the higher levels, you would have more of the land animals and the plants. And so, you know, that it in general makes sense to me that the progression, the order that we have.
So I just want to clarify, because I find that this is often something that's misunderstood, is that we have sea creatures at every layer. Like
Well, yeah.
you can find like bivalves, like clams, at the topmost layers, in the middle layers, in the bottom layers. Like you can find them in every layer. So it's not like we just have the sea dwelling animals at the bottom and land dwelling at the top. Like that's not the order of the fossil record. like the order of the fossil record, like you do have a point where there's no land animals, but you still have those same sea animals in the top and the middle layers as well.
And that also does make sense according to a worldwide flood, right?
Mhm.
Because you would have, you know, sediment, you would have things that were mixing around. And so you would have sea creatures, you would have, and then of course with mountains being uplifted and stuff, that's why we have fossils, ocean fossils on mountaintops.
Now, see, I would agree with you that in a flood, we would expect to see things mixing around. But again, like that just does not describe what we see in the fossil record. Like we don't just see this mix of all these organisms like we would expect to see from a flood. Like they are sorted into very specific orders, and they're not sorted by body density or mobility or habitat or like literally any of those physical characteristics. They are sorted by their species. How does water know how to sort different species that are like the same density? Like water cannot do that. And again, I'll just say at the bottom layers, we have single cells. It's not like you have these things that you would normally find like bottom of the ocean or whatever, like for like a huge amount of the fossil record. Before you have any animals, sea dwelling or land dwelling, you just have single cells for a huge, like the majority of the layers. So like that doesn't make sense.
But I mean, if you like dug a hole right now, right? Like if you just started drilling a hole, and Howard's waiting backstage, so he'll probably come on and tell me what he'll find when he drills a hole, since he's done a lot of oil drills. But basically, you would find right now, like in the top layers, you would find various creatures, and if you kind of like trace the ecology going down, right, you would probably eventually get to layers where there wouldn't be worms, there wouldn't be insects, but there would still be bacteria and things like that, right?
Yeah, it's just that a flood would not be depositing layers where there's literally not a single multicellular animal in them. Like if a flood was depositing these things, you would expect for there to be a lot of detritus, a lot of plant material, a lot of like animals and shells and things like that. But it's like 100% uniform. We never ever have found just a stray bit of flood debris in the majority of these layers. I mean, it's literally just 100% uniform single-celled organisms.
But if we had a flood right now,
Yeah.
right, wouldn't there still be there would be some things that were greatly affected by the water, right? That would be all mixed up and everything like that. But like after the water subsided, then we would still be able to drill down and get to areas that only had bacteria, right? Like we would still be able to, if we just started, like we just drilled a big hole and then we were like looking at the layers to see what's there, right? Wouldn't there be parts that may have been affected, like water seeped down, but it seeped down to places where there was only bacteria?
So you're saying that the areas that only bacteria would have been the original like surface, they were those layers were not deposited by the flood. It's like they were like that was the surface level, and the beneath the ground,
like it was below the surface, below the surface. But I have to tell you, I'm totally making this up. Okay, like I'm making up my own idea. Okay, like I have no idea what a creationist geologist would say about what I'm saying to you right now. It's just my idea.
Have you heard of the channeled scablands?
No.
So that is like an actual mega flood that occurred in like the northwest United States. So like we do know what an enormous, like the largest flood ever recorded by geologists, like what it looks like, what kinds of deposits that it leaves behind. Like we do understand what mega floods look like in the geological record. And like so we would know, like if a flood was actually depositing these layers, we would know what to look for. And it's just that we don't find that in all these other layers. Like we find that distinctly at the channeled scablands. We know that that was from a giant, enormous flood. It's just that it looks very distinct and very different from all the other layers that we're seeing. And like,
Well, now, so because this is one of the things that I'm like, um, I would like to know then what is the evolutionary explanation for why we have so many fossils? Why do we have all these deposits? Because to me, when I look around, I see evidence of a worldwide flood everywhere. I'm in a plane. Everything looks like it's been affected by water massively. Like there's like so many, like, all of these massive sediment fossil burial sites. It looks like the result of a flood to me.
but you realize that it doesn't look like that to the people that spend their entire lives studying specifically what happens geologically when there's a giant flood. Like there are people that spend their whole lives like studying geology and studying like flood geology, like at the channeled scablands, and they don't see what you're seeing.
I can't explain what's in the minds of other people.
Okay.
And I'm happy to hear from them. And I'll let Howard on in a little bit because he's been waiting for a little while. And he'll can tell me his opinion. I've already heard it, but I'll hear it again. But what's the explanation for why we have
so many fossils?
and like why is there a whale buried in stuff that's supposed to be, millions of years worth of layers?
Well, because it was millions of years. Okay, I'll explain it. So
Okay.
you have a very rare process. Like, what's the probability of a fossil forming? And it's like 0.00001% or whatever, right? And then you multiply that by the number of years that that species existed on Earth. And if you have a really low percentage, but that species existed on Earth for like 25 million years, then you multiply those two numbers together, and then the odds of you finding a fossil of that species is whatever the product of those two numbers are. And it can get to be quite high. It's just a simple math problem. X times B,
Okay, but what do you see as the explanation for why we have so many massive sediment layers that are full of fossils? Like what I mean is like where the sediment was all deposited in one, like one sediment layer.
Well, like one sediment layer doesn't suggest that it was deposited by one event. It suggests that it was deposited by maybe one process, but like typically like those processes are really long, or at least on the order of several thousand years to like a few million years. It's just whatever processes are at work at that particular location on the Earth. If you have on net more sediment being deposited on that area, it's going to build up over time. And if there's like a lot of different living organisms in that area, then you're going to have a lot of fossils in that layer. Like that is definitely not a problem in the eyes of any scientists about like why there's so many fossils in these sedimentary layers. So I've never heard of that being raised as an issue before. I don't see how it would be an issue.
Okay. Well, I do think it's an issue because fossils take it takes a special condition to, and you do have to have massive sediments and water. And
but
so,
yeah, I mean, you don't necessarily just have to have, like, there are lots of different conditions that can form a fossil, and not all of them involve massive amounts of water. Like there are
rapid burial in sediments.
Yeah, usually rapid burial, or at least like some way to preserve it from like decay or whatever while it's being like piled up on sediment. But again, it was more so what the evidence that I wanted to talk with you about was more so the overall ordering that we see, because like it's not just that we have sea creatures and then land creatures, right? Within that land creatures, we've got a whole lot of layers where there's no mammals at all. And then we've got a whole lot of layers where there's no dinosaurs at all. and like that is just crying out for some sort of explanation. And to my knowledge, evolution is the only explanation that could possibly explain that. Like, why do we have birds up here and we've got, flying like pterodactyls and things down here? When they both can fly, they should both be able to fly away from the flood, and if they're getting deposited, they should be in the same layer.
Okay, that's a good point. I
So,
like
and
that
you
point.
have a similar thing with like a triceratops and an elephant. If a triceratops can get away from a flood, an elephant should be able to get away, and so they should be in the same layer. But like, we
That's a good
clearly
point.
like the ordering is not in a way that could be explained by a flood. Like, and like, I don't know. Have I brought up the point about pollen fossils with you before?
Yes, and it was strange that you brought it up on the same day. You didn't watch the beginning of the stream, but I showed pollen from a Cambrian layer.
Pollen in a Cambrian layer.
I believe that's what it was. Yeah. I'll have to go back and look because now my mind, I'm a little bit fuzzy, but I think I brought evidence of pollen in a Cambrian layer. So,
And this is obviously something that would not be recognized by the scientific community.
no,
So
it was published in Nature.
yeah, that doesn't sound
Okay,
right.
just
to
like
me,
like
but-
look, let me look it up. Let me look it up.
okay.
Okay. But yeah, well, maybe we should let's look that up and we'll talk about it again because Howard's been waiting backstage for quite a long time. So I want to
Okay.
give him a chance. But can we reconvene on this? I will even send you what I find on what I'll find the article that I sent. It could have been in a slightly higher layer, but I thought it was the Cambrian, but it may not be. So I'll look at it and I'll send it to you and then we can talk about it again.
Yeah, because my understanding is that pollen first appears when you have pollinating plants in that same layer. And then in every layer where you can find pollinating plants, you can find pollen. But in the layers where you can't find pollinating plants, you also cannot find pollen. Now, you
Okay.
can find things that might be able to superficially resemble pollen upon like a cursory inspection, like a spore or something like from a fern. But there are some distinctions that you can make comparing like spores and pollen, and you can tell the difference.
Oh my gosh. It's actually in the Precambrian. The
And what
Precambrian.
is the source from?
Arema supergroup. It's supposed to be 1.7 to 2 billion years old.
Mm-hmm.
And yeah, that's it. It was found and it was published. So I'll send the article to you.
Can you
That
link
was
it in the
actually
chat here so I can look at it?
I don't have the article. I only have what I wrote about it pulled up
Oh.
right now. So let me.
Wait, so
but
what
have
layer
it
did you
somewhere.
say? What did you write about it?
I have it somewhere. It's pollen found in the Precambrian. It's called the Roraima supergroup. Roraima.
Okay. And
Okay.
I'll just put myself on mute or whatever while I look into that.
Okay, yeah, I'll put you backstage. I'll let Howard on, okay? And then if you want to say something in a little bit, I'll maybe let you back on if you're still there, or we can regroup for another time. But look it up, yeah.
Good evening.
Hey, Dr. Feldman, how are you?
I'm doing well. Let me see if I can adjust this a little bit better. That's a little better, maybe. Can you hear me okay?
Yes, I can.
All right. So several things I want to say. First, I looked at that pollen paper and I was going to correct you that it was Precambrian, not Cambrian. And the problem with that is that the rocks are metamorphosed, but the pollen is pristine. And so it is just so obviously contamination. If there was really pollen in the Precambrian, it would be everywhere. It wouldn't be just one or two spurious finds. It was published in a respectable journal, and it's good that people are allowed to do that kind of thing. But when you look at all the evidence, there's just no doubt that it's contamination because pollen today is everywhere. And there are a few spurious reports of pollen from places where it shouldn't be, but it would be everywhere. Today, pollen is so durable, it's blown from Africa to North America. I mean, it blows across the Atlantic and it is everywhere. In deep marine sediments to just about anywhere you have sediment being deposited, you have pollen. And yet when we look at the Precambrian, there's this one or two reports, and people have looked at it in depth, and it's not there. And then when they look in the Paleozoic, they've done a lot of analyses, and there's no angiosperms. And yet, how is that possible? You know, if you look at what's growing on the coast today, the salt marshes and mangroves, the very first thing that would be encountered with rising sea level would be angiosperms. And yet there's none until you get to the, I forget when angiosperms come in, sometime in the Mesozoic, but there's none. And people have looked at it intensively in the not just the Precambrian, but in the Paleozoic. And so you would really expect to see some angiosperms there if they were existing on Earth at the time. There's no sedimentologic mechanism that could separate them out. So that's the fossil record. There is a huge problem for creationism to explain the complete lack of angiosperms. And what they do is they hang their hat on these very few spurious examples that just fall apart pretty quickly.
Well, do you think the sudden appearance of the angiosperms is a problem for the evolution side?
I think what Grayson's, I would love to see more transitions, but I think what Grayson said is if you look at the broad patterns of the fossil record, they don't match creation because, you know, for example, with fishes, you're right, the first fish is a fish, but there's precursors. The specimen that Dr. Warner was showing, he completely messed that up. He was showing an example called Pikea, and that's not even a fish. Everybody agrees now that's not a fish. And so he was seeing things that aren't there. And he clearly wasn't up on 10-year-old literature. So, you know, when we look at fish, for example, the earliest fish, we see chordates that aren't fish, that aren't vertebrates. And then we see vertebrates. But the earliest fish are very simple. You know, unlike almost all living fish today, they lack paired fins, which, you know, almost all fish except hagfish and lampreys, every other fish has paired fins. They lack that. They lacked jaws. The early fish didn't have jaws. And when you look at the early fish that are preserved in, say, the Ordovician, where they really become common, they don't look anything like modern fish. And modern fish are entirely missing. So how is that? I mean, there's no sorting variation that would deal with that. When you said that the fossil record goes from marine at the bottom to terrestrial at the top, it absolutely does not. It goes back and forth. It goes back and forth over and over again. And so you have, you know, marine, terrestrial, marine, terrestrial, marine, terrestrial, going back and forth in a way that doesn't make sense. In the Precambrian, you know, I think what Grayson was saying was absolutely correct. There's not a single footprint, not a single bone, not a single scale or tooth, and those things are so easily preserved. There's not a single plant leaf anywhere in the Precambrian, and yet we have terrestrial environments. I mean, we've got river deposits. You know, what kind of a river lacks plants? Well, the only one that I know of is rivers that form when plants didn't exist. You know, like rivers that are on Mars. We see, not modern rivers, but we see ancient rivers, but there's no, you know, nobody's ever been there to look for fossils, but, you know, from the rovers, there's no indication of fossils. And so I think the Precambrian is a huge problem for creationists because why isn't there a single footprint or a single bone in the Precambrian? There's lots of river deposits. Yeah, sorry, I interrupted you.
By the way, I didn't mean to say that there was no other layering, okay, but I'm saying at the lowest layers, it's marine fossils.
No,
right?
it's marine fossils, but it's not marine deposits. Absolutely not. It goes back and forth. The belt supergroup, I'd have to look this up. It's several kilometers thick in Montana, and it's all fluvial. So it just depends on where you are. In some places, the lowest fossils are marine, absolutely, but the lowest deposits are not. There's lots and lots of terrestrial deposits in the Precambrian. They just don't have fossils. And so that's a huge problem. Like, why would they not have fossils? How do you have rivers without fossils, and river channels, river deposits, soils without plants? You know, we've got lots and lots of evidence that these were terrestrial environments, and yet they completely not just lack terrestrial fossils, they lack any fossils. And so how could that have happened unless the life had not yet developed on Earth?
Well, I'm out of my depth on that because it's not something I've looked into. But I mean, I'm just making up stuff as evolutionists often do. Okay, so I'm just making up stories right now. But I mean, we have lots of underground, like water, like springs and things that are underground right now, where we probably wouldn't find a lot of animals there either, right? So isn't it possible that these are just deposits that were of sediments that did not have animals living in them?
Well, what kind of environment would that be?
Well, I just described, like right now we might have an underground spring
Well, but that
where we
underground
tap in and get
springs
well
don't.
water and that kind of
Yeah, but
stuff.
you don't get sandstone deposited in underground springs. I'm not sure how that would work. I mean, we've got lots of evidence that these are terrestrial deposits, things like raindrop imprints and mud cracks. And so we know that they were subaerial. They weren't underground. We've got rivers that look just like river deposits today. And so the evidence is overwhelming that we've got terrestrial deposits. So we don't have terrestrial fossils. That's true. They don't appear till much later, but there's lots and lots of terrestrial deposits. If you look at just the record of terrestrial deposits, what you see is the gradual appearance of life. The first life is kind of these little marshy plants in the Silurian with a few arachnids. And then later you start getting larger trees, but the first trees don't look anything like trees living today. And then you get insects coming in and then terrestrial vertebrates coming in. But the idea that the creationist idea that you've got marine deposit at the top and terrestrial marine at the bottom and terrestrial top just doesn't fit the evidence. Where did all the sediment for fossil layers come in? From weathering of other rocks like granite or basalt or metamorphic rocks. There's lots of sources of sediment. That reminds me of something else you said, all the fossils. Why are there so many fossils? We see fossils forming today under normal everyday conditions. There's a type of limestone in the Bahamas called beach rock. It's like half the volume is fossils, and it's forming today. You can virtually watch it form. I mean, there's artifacts like Coke bottles and other types of bottles and other artifacts that have been incorporated into the limestone, proving that it's young, and it's filled with fossils. So you don't need special conditions to form fossils. Grayson got that wrong. You need special conditions to form, well-preserved fossils like a perfect fossil fish. You do need special conditions for that. But to get just like a shell preserved as a fossil, you do not need special conditions. We see this happening today in abundance. And so when you look at the sedimentology and the paleontology of the ancient, with a very few exceptions, it looks identical to things that are forming today. There's nothing special about it. There's
Now, see, I've heard something different than this because, when I'm listening to a geologist like Monte Fleming, who says, actually, what we see today is, the most massive amount of sediment deposits that we find today are like, okay, maybe the Ganges River Delta or something like that. Like, and the comparison, when you compare the type of sediment deposits that are happening right now and look at what we actually have in the fossil record, we had massive amounts of moving sediments in the fossil record, and we don't see anything on that scale today.
That's not true. I don't know who this guy is, but that's absolutely not true. And when you say massive amounts,
in geology, he has the same credentials you have. So he's saying something, you're saying something, and you have the same credentials.
How long has he worked as a professional geologist?
I don't know.
I've worked as a professional geologist for 30 years. I've written 2 books on it. I've published a couple dozen papers, more than that. How many years has he worked as a professional geologist?
I don't know.
Okay, probably none.
But
and so I teach this stuff for a living. Rebecca. I mean, I go into oil companies and I teach people how to do this. I've done it. I've done a lot of work on this. There is, with very few exceptions, when you look at the details of the sedimentology and the fossil preservation in the ancient, there's very few things that we find in the ancient that you can't find forming exactly the same way today. Now, there are things we see in the ancient that you don't see today. You know, we saw there's a massive asteroid impact at the end of the Cretaceous, and we have never witnessed anything like that. There's times like the Burgess Shale. There are some very unusual, very special types of preservation, and we don't see that forming today. But those are rarities. Those, things like the Burgess Shale that represent exceptional preservation represent a tiny fraction of the fossil record. The vast majority of fossils and the vast majority of rocks don't look like that. So, if you go to outcrops of any sandstone, you would be hard pressed to find any characteristics of that sandstone that you cannot find forming today in loose sand. The sedimentology looks identical. Now, what is different is, if the bones might be dinosaur bones rather than, mammal bones. So that would be a difference. But the sedimentology, all the evidence, and oil companies have spent huge amounts of money, millions and millions of dollars, coring and trenching and other ways investigating modern environments. And when we look at the ancient, it looks identical. It just looks identical in almost every case. Not every case, but almost every case. So the idea that there's some difference between what we see in the ancient and what we see today, if the flood was real, where is the difference? Where is the differences? I don't see any. And I've looked at a lot of rocks all over the world.
What kind of difference do you think needs to be there?
If
the flood happened.
Mm-hmm. Yeah. So, for example, how do you get river channels forming underneath a worldwide flood? I don't know how that happens, and yet we see lots and lots of evidence of river channels in the rock record at all different levels. And so how does that happen in the middle of a flood? And, there are certainly marine beds that are widespread, like in the Mississippian. You have these beautiful marine fossiliferous limestones that extend across a good part of North America. But below and above them, we see river channels. So then how do you get river channels forming? And it's not just that we see river channels, we see whole river networks. The most famous one that I know of, the largest one, is at the beginning of the Cretaceous. That work has just come together in the last maybe 10, 15 years. And not only do we see lots and lots of river channels, we see a whole Mississippi scale river system that is trending to the north instead of to the south. And we actually see beautiful examples in seismic data sets. I know that I'm using words not everybody knows, but we use sound waves to image the subsurface. And we see Mississippi scale river deposits in the subsurface at the northern end of this, which could only have been formed by a very large river. That was, but the river system like that takes millions of years to form, and yet it's sandwiched in between marine deposits below and marine deposits above.
Look, I'm out of my element here, and I will say that, let me respond to this comment real quick, but I want to respond to what you said too. But Mavis says, Rebecca is cooked, but she doesn't care. She'll be on live tomorrow lying some more. Look, I'm not lying. I'm trying to tell people a truth about reality, that God is the creator. God created. He loves you. You were not a product of natural processes. For me, I cannot answer everything related to geology. Okay. I am way out of my depth on this topic. Okay. What I am attempting to do is show you why evolution is false. And sometimes these topics come up that I don't have the knowledge about. And so, this.
Okay, so let's talk about evolution then.
But hold on, let me respond to what you said, because a lot of what you're describing sounds like things that would be very possible in a worldwide flood, where you would have various water, movements of water. And so I'm not I don't fully understand why this couldn't be consistent with a flood?
The sedimentology is just too different. So first of all, we have for each sedimentary structure, like a trough crossbed or a current ripple, we know the range of conditions under which those can form, and you can if you have current ripples in sandstone, you can extract from that, the direction the water was flowing, the speed at which the water was flowing, and approximately the water depth. And so those are all, when we extract those things and we look at the succession and look at the geometry, it's absolutely inconsistent. The sedimentology is completely inconsistent with any explanation other than a river. And we have the associated soils, which take hundreds of thousands of years to form. And when we look at the ancient, it's not just that we have soils in the ancient, but the soils duplicate the range of soils we see forming today, mostly due to different climate. So it's the range of soil. And when we map these things out in the ancient, they map into climatic belts that wouldn't make sense if in a one-year flood. We also have paleomagnetic data that shows, for example, in the Pennsylvanian, the equator was parallel to the Appalachian Mountains. And that wouldn't be possible. There's no creationist model that allows for that. And it takes time for all that to happen. And then when you look at the succession of organisms, just looking at terrestrial deposits, not looking at marine, just looking at only terrestrial deposits as you go through, they get more and more similar to modern systems. And in the ancient, you're lacking plants and animals that are everywhere today. There's no ecological zonation that will allow that to happen. And then, of course, that's on top of the fact that you're going back and forth between marine, terrestrial, marine, terrestrial, marine, terrestrial. And in the Precambrian, I think that's a real problem, that you've got thousands of feet thick successions of river deposits with no fossils. And yet you can't get river deposits today without at least some plant fossils and some pollen and, commonly some animal bones. And yet we see it's not just that it's rare in the Precambrian, it's absent. Not a single plant fossil.
Well, what is the problem with thinking that these are underground, like they were underground sediment? And like I said, I'm just making this up, so I don't know.
Yeah. Well, the problem is superposition, that there's no way when you have the ground surface, then you have a layer on top of that, and a layer on top of that. How do you insert a layer down here? They have to be stacked in order. There are some very rare circumstances where you can get things injected, but that's easy to see in the rock record. So these things, and we know from things like mud cracks and raindrop imprints that they were severely exposed, because there's no other way to generate those. And so we know that they're terrestrial, and there's soils in the Precambrian and in the Cambrian. There's no plants or animals in the soils, but there's chemically weathered soils.
And do you agree with Grayson when he says the only explanation for the ordering that we have of the fossil record is evolution?
I think, let me be careful about the way I state this. It's the only explanation I've heard that is consistent with all of the data. That if the Precambrian represents pre-flood, I don't think it's possible to reconcile a pre-flood world in which there were rivers that don't have plants and animals in them. I don't know how you reconcile that. And we know they're river deposits. Dr. Warner, in that video that you looked at my suggestion, said over and over again, there's no river channels he said there's no river channels in the Cambrian, no river channels in the Ordovician, and he went on and on. It was just completely wrong. He just wasn't looking at the evidence. And so when you look at the succession of organisms that appear associated with river channels, it is a succession. Now, each individual organism does appear suddenly, and for some organisms we have, for most, let's be honest, there's no transition, but there is a succession that does make sense with evolution and does not make sense with any other explanation that I know of. Why would we have an order to which the plant fossils occur, with angiosperms not coming in until late in the Mesozoic. And so this idea that these animals are all mixed with modern and ancient animals, modern fossils, just doesn't work. Most dinosaurs are not associated with any angiosperms. A few are, the very, very latest. And when we look at the plants and animals in the Pennsylvanian, which I've worked a lot, we see these river valleys that are filled with terrestrial fossils, and then they have marine and non-marine or marine fossils above and below. And we see soils that would take thousands of years to form that are associated with the river channels. And so the whole flood, I'm more of a sedimentologist and stratigrapher, but the whole flood model just disappears. It's absolutely inconsistent with the rock record. And from an evolution point of view, I think the Precambrian is a huge problem for creationists. You just can't explain why there's no fossils, no fossil plants. We have great preservation, the Ediacara fauna that Grayson was talking about, which has now been increasingly well known, shows that the preservation potential is there, because there are Ediacaran sites on every continent, maybe except Antarctica, but every other continent has Ediacaran sites. So the preservation is certainly there. So if there were plants around, if there were fish around, we would see them, you'd think, because there's so many Ediacaran fossils. There's thousands and thousands of them, but not a single fish, not a single bone, not a single tooth, not a single leaf, no roots, no bark. And so how is that possible?
Well, I mean, what's wrong with my explanation that we would expect, that we're talking about bottom of the ocean stuff, right? Like if sediments were deposited in the flood, then we're talking about environments where there wouldn't probably be that kind of thing.
Well, that depends on where you put the base of the flood. Do you include the Ediacaran as a flood deposit? Because most creationists put the base of the flood at the great unconformity, and I'm talking about things that are below that.
Okay.
And we know that they're terrestrial. We know that the Ediacaran faunas are usually interpreted as a nearshore marine, that they are marine but shallow water. That's based on associated sedimentary structures and facies patterns. And so it's not, there's no reason to think that it's at the bottom of a kilometer of water or something. There's no evidence to support that. So I'm talking about the pre-flood deposits. We've got great preservation, so it's not a preservation issue. We've got, successions that are kilometers thick that have been intensely studied. And there's this, one or two odd occurrences of pollen, and that's about it. And yet there's no plants. I mean, not a single plant. Like a macroscopic, like a leaf. And leaves are very easy to preserve. There's just, there are places where you can go. Like I lived in Lawrence, Kansas for a long time. You could go to a spillway of a lake, spillway of a lake, and just collect bucketfuls of plant fossils. It's very, very, they just preserve so easily. And yet not a single leaf in the Precambrian, kilometers thick. And so, and then when you look at the succession of organisms, yes, trilobites appear suddenly. But we do see a succession of different types of animals in the Ediacaran. The first fossils are prokaryotes. Then we have eukaryotes, then we have multicellular animals, then we have shelled animals, and then eventually we have fish that look very simple without jaws. And then we have on top of that more complicated fish with pectoral fins, like all the fish today, except for those two examples. And then you keep getting more and more similar to the modern fish, and then eventually you get whales at the top. And so there's a succession, although each individual appearance is commonly abrupt. We don't have intermediates for everything. We do have some nice intermediates for some things, though, like the transition from the therapsids, which are commonly called mammal-like reptiles, even though they're not reptiles. The therapsids. So an example of a therapsid is a pelycosaur. Pelycosaur is the finback reptiles. And then that transition from there to mammals is very good. That's a very good transition. And so I think the order of the fossil record is a real problem for creationists if you look at the whole thing, including the Precambrian. I mean, a lot of times creationists just start looking at the Cambrian up, but you have to look at the whole thing, and it will be an incredible problem. And I think, for the flood, there's no sedimentologic record of it. None. I mean, we've got record of marine deposits, but they look just like marine deposits forming today. And this idea that you can't get fossils forming today is, I've heard many creationists repeat that fossils aren't forming today. It's just wrong. You know, it just
Well,
shows.
I don't think I said that. Did you hear me say that? I don't think I said fossils aren't forming today.
No, you didn't, but I've certainly heard other people say that. But you did
Yeah.
say, how can you get widespread fossil deposits without the flood? And there's no reason why you can't.
Well, I don't know. I haven't heard a good explanation for it. Like,
Well, if you have a shallow sea and there's shells forming on the shallow sea, why wouldn't they form fossils? I mean, shells form fossils very easily.
right, but I mean, you have like massive deposits where you have like animals in action that seem to have been rapidly buried, you know.
That's absolutely true. All the evidence that creationists point to for rapid burial, there's two things that you should know, or maybe three. Let me see if I can get this right. First of all the evidence for rapid burial that creationists cite was first discovered by mainstream geologists, not by creationists.
Oh, that's fine. It doesn't matter who discovers
Okay.
it, does it?
Second, creationists like to claim that somehow this is evidence against long time frames, but it's not, because rapid doesn't mean recent. There absolutely does have to be rapid deposition to form like the Solnhofen limestone in Bavaria. I don't know if you're familiar with that, but that's where Archaeopteryx is. It's also, the Solnhofen has this great fossil where it's this horseshoe crab, where there's this massive spiral trail, and at the end of the spiral is the horseshoe crab. I mean, it's just absolutely amazing, absolutely rapid deposition. But those deposits are not as big as you're making them out to be. They represent a tiny fraction of the fossil record. There's just a few locations around the world. You know, if you look at the locations in North America that have well-preserved fossil fish, especially small fossil fish, which are more difficult to preserve than big ones, they're rare. They're incredibly rare. There's maybe a dozen in all of North America. The biggest one would be the Green River Formation, which is pretty widespread. But most of them are tiny. Like there's one that I worked in Kansas that was maybe 100 meters wide. And if you step 1 meter outside of that, no more fossil fish. I mean, they're just tiny. And they represent very special conditions over very short periods of time. But the vast majority of fossils don't look like that. They don't represent rapid deposition. They show evidence of very slow deposition. Things like coral reefs growing in place, and we see a succession of different kinds of coral reefs through time. That doesn't make sense it doesn't make sense for a flood, and it doesn't make sense for creationism.
Okay, well, thank you for sharing your evidence.
I don't think I mentioned very much that I had mentioned before. I think most of this was new to you.
Actually, I feel like you've said a lot of this stuff before. So,
but I think I would really like you to investigate why there's no bones in the Precambrian, no teeth in the Precambrian, no fossil fish in the Precambrian, no footprints, even though there's lots of raindrop imprints, so presumably you could get footprints, not a single leaf fossil in the Precambrian. And then if that's pre-flood, why don't you see those things?
Right. Well, and I appreciate that, but as I told you, like my mission is not to prove that young earth creation is true or that the flood happened. I believe those things, but my mission is to show you why evolution is not true. Okay, so
well, but how does that Precambrian evidence fit with a world in which evolution is not true? Because I think the only explanation for why you don't get those types of organisms preserved is that they didn't exist anywhere on Earth. That you had stromatolites and then Ediacara fossils, but nothing else. And so that doesn't fit your model, I don't think.
And I already agreed when I was talking with Grayson at the beginning. I said, look, the fossil record is difficult for my model. Like for me. Now, there's probably creationists who are cringing right now and saying, I'm not doing a good job representing, okay, because I have not spent a lot of time looking into this. Okay, so I'm sorry, young earthers who have much better geology knowledge than me, okay? From my limited knowledge, I find problems with the young earth model with the the way that the layers are. Okay. But I also don't think the fossil record is helpful for evolution. I think now I'm going to consider overall Grayson's point that he made tonight, and I will think about that and report back after I've like considered it. But in general, the fossil record is a problem for evolution for the reason that you even admitted that we have the abrupt appearance of most forms. And so this does not show the progression that we need for evolution, which is supposed to be very slow. And, we don't see that progression happening. So do you agree that's a problem for your model? I'm admitting the problems with my model. Are you admitting the problems with your model?
I would like to see more transitions, but I think there are lots of transitions. And what's really impressive to me is that the order in which the fossils appear, the succession, is the same worldwide. And if this was all deposited over a short period of time by some mixing of the flood, it wouldn't work. I think the only way you can get that succession to be repeated over and over again in many different places is if there's a succession to the appearance of those organisms on Earth. And whether you think that that's a series of like a million special creations or evolution, I think both of those would be, okay. I think the order is tough if you don't think it's evolution. I don't know what other process it could be, but I would like to see more transitional fossils. But there are a lot, especially in invertebrates. There's in the forams and in coccoliths, we see wonderful transitions. The problem with vertebrates is you just don't get enough of them. With microfossils, you can collect one bucket of sediment and get, a million microfossils. And trying to find a million dinosaurs is pretty tough. But even the succession of dinosaurs, here's another one that's interesting from an evolutionary perspective. In the Cretaceous, there's record of a seaway that stretched from the Gulf of Mexico up to the Arctic Ocean. Okay, and so we see marine deposits in that stripe, kind of centered on the Utah-Colorado border. So one shoreline would be in the center of Kansas. The other shoreline is in the center of Utah. So it's kind of that wide and then stretching across. And then we see different dinosaurs on one side than the other in the Cretaceous. And so the explanation is that once that seaway was established, they evolved separately because they couldn't cross the ocean. It's like hundreds of kilometers wide ocean. And yet from a creationist model, how does that happen? Why would there be different dinosaurs on both sides of the seaway? And so, we see evidence of geographic isolation leading to differences in the succession of fossils. That doesn't make sense without evolution. So I think there's direct fossil evidence for evolution. And when you look at the succession of dinosaurs, you see beautiful transitions, like the transition leading up to Triceratops is very nice. The early dinosaurs don't look very much like Triceratops, and they end up looking a lot more like Triceratops. Why
see, this was going to be one of my examples of the sudden appearance, because don't we have no transition to Triceratops? We just have like this Triceratops.
That's not true.
Okay, what would be the transition? Maybe
off the top of my head, I don't know the names of the fossils, but my guess is there's a Wikipedia page on them. There are some dinosaurs for which there's no transitions for sure, but the general succession shows it makes evolutionary sense and not creationism sense. Like why if creationism is true, why would Stegosaurus never occur with Tyrannosaurus? Stegosaurus is always in older layers than Tyrannosaurus. So why is Tyrannosaurus only in Western North America and never Eastern North America? It's because that seaway was there, so it couldn't get across. So when you look at all the fossil evidence and don't just cherry pick the fact that there's no transitions to bats or 100 other different types of fossils, when you look at the entire succession, I think you need evolution to explain it, or millions and millions of separate creations in order. So I think it just doesn't work any other way.
Okay. Well, have you looked into any of the other, because I know you like to stay on geology because that's your area of expertise, but have you considered any of the other, evidence that I've brought against evolution?
Yeah, I think I'm not going to spend a lot. I have a day job. I'm not going to spend a lot of time investigating things. I'll put it this way: every time I've investigated a creationist claim in an area where I have expertise, they've been wrong. Like Dr. Warner is probably the worst example of all. I don't know why you respect him, because he says so many things that are just blatantly false, that are easily shown to be false. I mean, and
Okay.
this guy, for some reason, has all this credibility, and I don't get it, because it's so easy to show that he's not telling the truth. And he may
Wait,
believe he's telling the truth. He may not think he's lying, but he isn't telling the truth.
wait, I've asked you before, please do not come on and talk bad about Carl Warner, because I love him. And yes, I'm not saying that all of his information is perfect, but why do I respect him? Why does he have my respect? Is because he set out on a journey and he spent tons of money and he tried to find out the truth about evolution. And so he basically spent his life doing this. And he started his journey around the time that I was questioning and asking God to show me the truth about this. So I feel like he's an answer to prayer.
So
And
then why don't you respect me? Because I've spent my life working on this.
well, why do you think I don't respect you?
Things you've said in emails.
Well, I don't respect the dogmatism.
I
Okay, I
deny
do
that I have
respect your
dogmatism.
scientific work,
Well,
but I don't respect the dogmatism.
Well, I don't think I am dogmatic. I think your criticisms were not well placed. But if you want to talk about some of the things, I think complexity is something that fails repeatedly. You need to make a lot of assumptions for complexity to be a problem. One issue with complexity is finding a way to tell me what is complex and what isn't. I don't know of a way to measure it, and we know from the evolution of structures that are preserved, like the hand, that there's a series of stages that go through different functionality. Like the early bones that created, eventually became our hand, were fins, not hands. And so for a protein, for a hemoglobin protein or whatever complex protein you want to choose, the early progenitors of that protein might have very different functions, which is what the guy before Grayson was saying. I can't think of his
Dr.
name.
Thompson.
Yeah. So he was saying those, you could have proteins that have very different functions. Then they come together to make a much more complex protein that has an entirely new function. And so you don't have to maintain the same function back through time. And so that's why to me, all arguments about complexity fail for that reason, that you can't show that you would have to show that there's no possible evolutionary path, which obviously is technically impossible because they're so complex and there's no evolutionary history. So it doesn't matter whether you have one example of complexity or 1,000, it fails all for the same reason. You once said in one of your videos that you can't have blood without blood vessels and you can't have blood vessels without blood. That's absolutely not true. There are organisms today that have blood without blood vessels. And so, these things
I don't know if I said you couldn't. I said, what would be the point of evolving all these blood vessels when you have no blood? How would that be selected for?
I could find the video where you said that, because it really perked up my ears when you said that. But there are organisms today that have an open circulation where there's no vessels, and then you could see how vessels, adding that gradually, would increase the fitness of the organism to do whatever it's doing. And so I could see an evolutionary.
Well, it sounds
path.
like you're happy with having these stories. Personally, I think that you're really underestimating the problems with getting, the first organism, or any organism, like even after the first organism, the diversity of life on Earth today. by a step-by-step process like that. So, I mean, have
Well,
you considered?
there's certainly a lot of gaps in our knowledge, but that's not evidence that you need a miracle to fill those gaps. That's called God of the gaps theory, which has been proven to be wrong.
Right, but this isn't God of the gaps. This is based on what we know. And what we know is that every organism, even the simplest organism, has an incredible amount of information in its genetic code. And it has an incredible amount of processes that need to happen that all have to be in place at once to keep it alive. In a simple cell, I'm just talking about even one cell. So you have to be able to explain first the origin of information. Now, what we do know from all of our scientific observations right now is that information is only produced by specified information. Specified complex information is only produced by intelligence, okay, by people.
Can you give me an example?
Yeah, computer code, right?
And
We don't
so
have
wait a minute. Let's just go with what we know. So who writes
I'm going with
who
what we
writes
know.
computer codes?
People.
Okay, so can you give me another example of something complex being created by intelligence?
Yeah, a car.
And who creates cars?
People.
Do you have any example where something complex has been created by anybody else other than people?
No.
So that means that everything complex like DNA must have been created by people using your logic?
Well, no, I'm using the logic of needing an intelligence, right?
Well,
Do you know of another?
But let's go with what we know. You don't
Right.
know that an intelligence other than people can create anything.
Hey,
all we know, all the examples you have are people. And so using your logic, that would mean that if only people can create designs, whenever we see a design, we don't know the creator, it must be a person. Let's only
if
go
that's
with what
the
we know.
conclusion you make, that is up to you. Okay.
No,
I think there's another source of intelligence.
I reject that logic entirely. I'm just using your
Okay.
logic. You don't have any evidence that an intelligent designer other than people can create designs.
I feel like you're avoiding the main point with like a little trying to turn it on this one thing.
I'm not.
Right? So what is your proposal for the source of information?
I have no idea.
Okay, you don't know, but you're willing to. So you admit that right now, what you believe about life and how it came about is based completely on faith, not on science.
No. I say that there are steps in evolution for which we have no explanation. Absolutely. There was a lot of progress made in the 50s and 60s on looking at the origin of organic compounds and how they could occur naturally. But basically it's stalled. And, as we've gone further down that road, it's really been hard to piece the pieces together. But that doesn't mean that you need a miracle for it. It doesn't mean that it can't have happened. It just means that we don't yet have an explanation.
Right.
And
we don't have an explanation
because we have so much other evidence that evolution did happen that I don't see, for every explanation we have, there was a time before when we didn't have it. And you don't have any evidence that an intelligence other than people can create design. You don't.
Well, if you, like I said, would you admit that we don't have evidence that non-intelligence can make I'm going back to the information, specified information, complex information?
I don't see a physical law that would prevent it. Like, what would prevent that from happening? I don't see a problem with information increasing in the genetic code through time. I don't know how the genetic code came about. I don't know what the steps were. But I don't see I don't see that increase in information violating any physical law. Certainly not the second law of thermodynamics. That's a red herring. So,
right. Well, I mean, the thing is that there are some things that are so improbable that it is reasonable to say that they're not going to happen,
Um,
right?
well, a lot of times when people compute probability, they do it making certain assumptions that don't work. For example, you could say, what's the probability that you would get your precise social security number? It's infinitesimally small, but that doesn't mean that there was some supernatural intervention. So the question isn't, what is the probability of a hemoglobin molecule evolving? That's the wrong question. The right question is, what is the probability of any protein evolving that could have that function? And you'd have to look at all the family of potential proteins of which we know nothing. What potential proteins would there be? And there might be millions of different proteins. And so it's not that one protein evolving, it's any protein evolving that has that function. And you don't know. And in fact, it's an unanswerable question, so you can't compute the probability.
Well, you actually, I mean, there have been a lot of computing of probabilities. Okay. And so the problem with getting even a single protein to evolve by natural processes, right? We have to consider the space of all possible of all possibilities with regard to that. And it turns out that getting a functional protein is very, very narrow in the space of all possible outcomes,
Well,
right?
you'd have to compute the possibility per unit of time and then multiply times the amount of time we have. And so that's the hard part. Is I've seen people say, well, there's only 1 in a million chance this could happen. Well, 1 in a million chance over a second, over a year, over a decade, and it's that time element that is very difficult to compute. So probabilities should always come with a time element. Like, it's not the chance, what's the chance of that I flip a coin and get heads? It's what's the chance that I flip a coin once and get heads? If I flip a coin 10 times,
Right.
very likely to get heads. And so that's the question, over what period of time. And that's the element I haven't seen.
Well, and actually, I can recommend a very good book to you if you're willing, because I believe those probability calculations have been done, and they have actually considered all possible events in the universe. Like, if all possible events, time and even action, like possible actions, possible movements, okay, have been calculated, and there's still not enough time and events to be able to get life to come about, even a simple cell.
I've looked at some of those calculations, probably not the ones you're talking about, and I've seen, flawed assumptions, and I'm frankly not going to look into it again because I'm working on my own books. I've got 2 more books in the mill, and that's really eating up all of my time. I'm editor on one book and I'm writing another book. And so I'm just not going to waste my time. Like I said, I'll say it again. Every time I've looked at a claim in an area where I have expertise by creationists, it's been false. Every time. I've yet to see a claim by a creationist in an area where I have expertise that is actually true or relevant to anti-evolution. And so at some point, I just am going to give up. I'm not going to continue doing it. And, I keep thinking there must be something there, and there isn't. And so it's possible that the only true statements that creationists make are in areas where I don't have expertise, but that would seem to be unlikely.
What causes you to say there must be something there?
Because so many people believe it. I keep thinking there must be something there. And yet, I've watched so many Standing for the Truth videos where they just make these absurdly false statements about geology and paleontology. And I won't mention any names, but people get on that show that profess to have expertise, and they don't. They're just making things up. And some of them are so easily disproven. I mean, it's just absurd. And so that's one of the reasons I'm trying to get on Standing for the Truth to present some of this evidence, because they presented so much geology that is just, their geologic evidence is just, as far as I can tell, completely fabricated. And I don't think the people that are doing this are being dishonest. I don't think it's intentional. I think they're so blinded by bias that they just can't see the evidence before them. And of course, you think that about me. So
Yes, I do.
But the difference between us, Rebecca, is that I've gone out in the field. I spent a lifetime working on this.
Right.
And when somebody spends a lifetime working on it and they come to your conclusion, you think it's fantastic. When somebody spends a lifetime working on it and they come to a different conclusion, you think they're biased.
No, I'm not going to say that you're biased about the geology. Okay. You've actually given me reasons to think you're not as biased about the geology. Okay. Like, for example, tonight you admitted the abrupt appearance of a lot of forms, right? I think you even said most. Okay. So and you have also admitted that you were surprised about the dinosaur soft tissue found in dinosaurs, and that you don't have an explanation for. So for me, those admissions are a good indicator that you're not so biased about your topic.
Yeah.
But I have where I've seen the bias with you is the anti-God bias. Okay.
You have no idea about my religious belief, and I am not anti-God. This is an example of you imposing your bias on what you think, who you think I am. So, that's your bias. I've never said anything anti-God that I can recall ever. Like in my whole life, I don't think I've said anything anti-God.
Then is there a reason that you won't allow the idea of an intelligence other than humans being the source of your life?
Well, there's several reasons. One is that as soon as you allow miracles, science stops. You just say, well, as soon as we don't understand something, a miracle did it. And that has proven over and over again to be bad. I mean, we just wouldn't discover anything if we allowed miracles. You have to start. The only way science can work is if you assume that miracles don't happen, because if you assume miracles do happen, every time you get stuck, you just say, well, it's a miracle. And, that doesn't work. Science falls apart if you use that approach. The second is, I had another point I was going to make.
Well, let me stop you on that point. And
the second is that, extraordinary claims require extraordinary evidence. This is something in science goes back, I think, about 300 or 400 years, but Carl Sagan said it in that way. And so if you want to present evidence for that, you need some sort of extraordinary claim that would actually fit all the evidence. And when I look at the fossil record, I just don't see it. I don't see how you can fit the fossil record into some sort of a creation event. And you had a guest on, I can't think of her name, that presented all the evidence for human evolution. I thought she did a great job. And I think it'd be very hard to fit that into any kind of and there isn't an abrupt appearance of humans. It's absolutely as gradational as you could ever want. I mean, if you line up the skulls, you can't tell where the boundary is.
Yeah, well, I also thought Erika did a great job presenting evidence, but I don't think I have a hard time fitting it in with my model. So, but what you said about if we allow for a miracle, then science stops. I don't think that's true. Well, because, people who we can approach science as a search for truth, right? And there's no mandate that it has to be, something that occurs by natural process. Where is the mandate for that? Like, where does that idea come from?
Because you stop searching for natural processes if you allow for miracles. And what's happening, that if you allow for miracles, you end up with God of the gaps. That's where you end up.
Well, the problem that you end up with, though, is that if you rule out certain explanations because of your determination to find a naturalistic one, you might be missing the truth about reality.
It's possible. But which truth would you go after? I mean, I've investigated many religions and they all have their own truths. And, it's not, one thing that really rubs me the wrong way is when, and you've done it tonight, you assume it's Christian creationism or atheism. And that seems to be your dividing line. And it's not the case. I mean,
No.
there's a lot of religions that have no problem with evolution.
You know what? You're actually this. Look, I literally wrote a book on this, Howard. Okay. This is about my experience of 10 years of living in Muslim majority countries. And this is Turkey, UAE, and Jordan.
Okay. I've been to Turkey. I haven't been to the others.
Okay, cool. We'll have to talk about that sometime. But basically, this is me trying to help Christians understand, appreciate, and respect the faith that Muslims have. Okay, so I very much appreciate, I understand that, it's not there's a spectrum. There are different, I do believe that Jesus is the savior of the whole world. Okay. But that doesn't mean that Muslims don't know God. So I have many Muslim friends that know God very well. And in fact, I would say some of my Muslim friends know God better than some of my Christian friends. So, I don't think that, you have to have all the correct information about God in order to know God. And I feel like God is calling you. I feel like God has been reaching out to you.
Well, I'll give you an example of why I think. Well, I'll just give you an example. We were talking about bioturbation, and you pointed out this article that had been recently published. There was a video on it about bioturbation, and you said, "Well, maybe this is God calling to you." But what was the signal? Because it was a terrible study that was just filled with errors and problems. Is that an indication of God's work? I mean, I read that article that you recommended, and it was just terrible. And so, you lost a lot of credibility with me when you said maybe this was God, speaking to you, that this article just came out as we were bringing up the topic. And, and I'm not, he uses outcrops that I know well, and he completely misrepresented them. I don't think he did it on purpose. I just don't think he's, got enough experience and skill to do what he said he was doing.
Okay. Well, whether it was God or not, I guess, it's hard to be sure.
Well, that was you that said that, not me.
I know. Well, it did feel like a very timely thing for me to see that came out. Not the article came out, but that podcast came out right after I had talked to you about this.
That's
so
true.
It did feel like it was a divine response. So, but as far as whether the paper was good or not, look, I thought it was good, but of course I don't have the expertise that you have. So I'm maybe I was wrong about that. I don't know.
You were wrong. I mean, I wrote to the guy, the first author on the paper. I think it was a 2-author paper. I wrote to the guy and asked him which outcrops he used for part of the study. And it's outcrops that I've been to many times. And he absolutely missed a lot of bioturbation in those outcrops. It's not just that he missed some of the bioturbation, he missed most of it.
Well,
that's how bad he is.
I do have to tell you that I thought about you the whole time. Me and my husband were on a trip across Utah just like last month. And I was thinking, where is the bioturbation? Why are there so many layers? I really wanted to have a conversation with you by every rock formation that I passed by, because, a lot of the things that I felt like you've told me as I go and look at the rocks, and especially here in Utah, I don't see what you're telling me. I see, layers, non-bioturbated, right?
Well,
I see a lot of
it could be hard. It could be hard for a non-geologist to spot the bioturbation. Most bioturbation in marine settings doesn't go down more than about 1 meter. So that means if there's a bed deposit thicker than 1 meter, it's not going to get destroyed by bioturbation. But there are lots of examples of thinner beds where you can prove that they've been destroyed with bioturbation. If you want to, I'm not going to do it tonight. It's, oh my gosh, it's too late. I'm sorry. I'm just looking at my clock.
I know we should probably
Yeah.
we
And
should
so,
probably end
but
it.
there's lots and lots of evidence that bedding is destroyed by bioturbation. But a lot of times when you're far away, the beds look pristine, and as you get close, you see that they're actually not. That the boundaries are fuzzy due to burrowing. And this is another problem for creationists, is that there's virtually no bioturbation in the Precambrian when things were allegedly deposited slowly, and then you go across to the flood boundary, bioturbation increases. Like this study, that's one of the flaws, is they didn't look at pre-flood deposits in their worldview. If they had looked at pre-flood deposits, they would have seen zero bioturbation. There's a few places in the Precambrian where you can find bioturbation, but it's very, very rare. And so that would have, if they had extended their study, that would have been a huge problem for them. So this is what I mean. Every time I see, every time, I don't know who Andrew is, sorry. Every time I see an alleged study that presents geologic evidence for the flood or against evolution or whatever it is, if it's an area I know, they're wrong. And so I just don't see where's the evidence. It just falls apart so quickly. And when it comes to proteins and genetics, I mean, I don't know anything about it. I took a genetics course in 1978 or something. I took a genetics course, and that's the last time I've dealt with genetics. So I'm really out of my water when it comes to that. Like you talking about geology, I'm just so out of my depth that I'm uncomfortable talking about it. And so that's why, all this stuff about genetics and probability and proteins, it's just, it's not my area. But when it comes to paleontology and the fossil record and biostratigraphy and the stratigraphic column and the sedimentologic evidence, overwhelming, the Earth is ancient. There is just no way around it. And the sedimentology of the beds we see in the Phanerozoic is almost entirely identical to things forming today. They're just, you can't find a difference, or if you can, they're very, very small. And there are deposits that are different, like the Burgess Shale and the Solnhofen limestone. I don't know of a modern analog for those, but those represents tiny, tiny fractions of the fossil record, of the rock record. So this is what gets me, is how wrong everything I've seen about geology and paleontology. I shouldn't say everything about paleontology, but almost everything about geology, certainly, that I've seen on creationist videos in books, and I've read a stack of them, is wrong.
Well, then if you don't like the young Earth creation, why don't you consider old Earth creation?
Old Earth creation with millions of special creations. Yeah, I don't know how to disprove that. I think it would be odd that they're all in a particular order, but you need millions and millions of special creations. So you need a special creation for the Ediacara fauna. Then you need a special creation for, there's trilobite zonation that extend for thousands of kilometers. And so you need a special creation for this trilobite, and then for that trilobite, and then for that trilobite, and then for that trilobite. I don't think it makes much sense, but you could, I can't think of a good reason why it couldn't be true. It seems unlikely. But a single creation absolutely is not consistent with the rock record or with the fossil record. And, the evidence from the Precambrian is just rock solid.
Okay, well, thank you for sharing.
I'm at my end. I have to go to bed.
I know. Yeah. Thanks everybody for watching. And actually I'll say goodnight to Howard, and then I'm going to review the evidence that's been brought forward like in the past, and the evidence that I've brought against evolution and the evidence that's been brought for evolution. So let me remind everyone, no one has challenged successfully any of the evidence I've brought against evolution. So I would love to see that. If there's any evidence that you can bring against the things I've suggested are problematic for evolution, or evidence against evolution.
All right. Good night.
Good night. Thank you. So let's review the evidence that's been brought for evolution. And all of this stuff about geology and everything, I've already said it. Look, I'm not going to put up all the evidence. Only if evidence is actually for evolution, that's what I'm going to consider. I'm not considering evidence against young earth creation. Okay, I'm not trying to argue for young earth creation. It is what I believe, but I cannot possibly tackle every topic related to young earth creation on here. What I'm trying to do is show people why evolution is false, and I think it can be shown to be false. And so that's what I'm trying to show you, is the evidence against evolution. So here's the evidence that has been presented in favor of evolution that I have accepted as evidence for evolution. Dr. Dan brought forward a mutation that doesn't cause sickness but protects against malaria. Erika brought the prediction of ape-human transitional features, and we found ape-men features we had features that were found that could be transitional between ape and human. Then we have Grayson, the prediction of a transitional reptile bird features, which was found in Archaeopteryx. Although a couple of points about that, Archaeopteryx is too old to be the bird transition. I believe that is the problem with it. There's a time problem with it, and I think that was it, but I have to look that up. And also, it did have fully formed wings and fully formed feathers. So it's kind of interesting because it's, why don't we have any transitions to feathers and wings? But anyway, going on. Grayson, the prediction of transitional amphibian fish features and then we found Tiktaalik. Okay, so that's the evidence that has been presented for evolution in prior episodes. And I'll consider what was presented tonight that Dr. Thompson brought and that Grayson brought. And if it consider it evolution evidence, then I'll put it up next time. And yes, I'm the one who decides whether it counts as evidence for evolution. It's my show. But if you want to come on and argue with me again about why I didn't accept something, then feel free to do that. And, at least your voice will be heard, even if I don't accept it. All right. So now the evidence that I've brought against evolution. Last week, I brought seeds, evidence against evolution, sudden appearance of seeds, problems with evolution of seeds, and, I brought the incredible complexity, integrated system, and chicken and egg problems related to seeds. So then also alternative splicing, the fact that right now there are little machines in your cells that can take a gene that codes for a certain protein, splice it and dice it, and make it into a specialized protein machine. That is incredible, and it's very hard to explain where the foresight came from, where that was able to be produced without an intelligence that set up that system. All right. Ribosomes. I don't even remember what I said about ribosomes. Just look, ribosomes. It's like basically a code reader and basically a 3D printer of sorts, if you could sort of call it that. But it's very difficult to explain how this complex machinery could come about by a natural process. It doesn't do any good to have a genetic code if you don't have something that can read the code and make use of it. And that's what the ribosome does. So circulatory systems, complex wow, this is going to take me too long to go through this whole list. Anyway, I'm not going to go through the whole list, but you can see these are the problems that the evidence against evolution that I have brought forward since the beginning. And people can come on and challenge that if you want to. I guess I did hear Howard say he challenges this idea of thousands of dinosaur fossils, no predecessors. So, but I need to see specifics. So if you're going to come on and challenge it, I'm not going to accept just vague, oh no, we do have that. Like you need to bring your example, bring your picture, bring your paper, bring bring your actual evidence, not just come on and say something. Okay. You have to actually show the evidence. So that's what I want to say. And appreciate everybody being here. And I want to remind you about, I didn't get to say this tonight, but 6 reasons, scientific reasons to reject evolution. Okay. First of all, the proposed mechanisms are grossly insufficient for producing the diversity of life on Earth today. These are some of the proposed mechanisms. These are the main proposed mechanisms for evolution. None of them produce new information, except the only one that has the potential to produce new information is mutation. And the problem with that is mutation mostly degrades organisms. So you have the problem of, where did the information needed for these organisms arise? And none of these evolutionary mechanisms, save for the possibility of mutation, even have a potential of doing that. Mutations. So second scientific reason to reject evolution: mutations degrade. Mutations are a problem for organisms. We see tons of horrible diseases and things that come about because of mutations. And even evolutionists agree that 99% of mutations are deleterious, meaning they cause something harmful in the organism, not something beneficial. So the problem is, for evolution, you've got to go the other direction. You've got to get something to go the other you've got to get things going in the other direction. Well, mutations are supposed to be the main driver of getting things to go in the other direction, but they have not been demonstrated scientifically to be able to do what needs to be done to get the diversity of life to appear on Earth. Third scientific reason to reject evolution: integrated systems require foresight. Integrated systems, which life is, even the simplest organism in life is a complex integrated system. And those systems, we know from our experiences, this isn't about what we don't know, it's about what we do know. We know that wherever we see an integrated system, it requires planning, it requires foresight. It's not something that comes about spontaneously by natural processes. Fourth scientific reason to reject evolution: numerous chicken and egg problems at the cell and system level. Every cell, every system has numerous problems where you have to have many things in place at once. The chicken and the egg problem, the problem is, if you're going to have a chicken, you need to have the ability to reproduce. You have to have the egg at the same time. Otherwise, next generation is not going to be there. So there are many things in life where both things, everything has to be in place simultaneously, or you don't get life. And so there are many things at every level of organization in an organism that there's just multitudes of chicken and egg problems if you try to make life come about by a step-by-step process. Fifth reason to reject evolution: the fossil record sudden appearance of forms. The fossil record is not a friend to evolution. Now, I will consider what Grayson said tonight about the overall form of the fossil record. I will look into that. But in general, evolution needs millions of years for organisms to grow and change. Why don't we have the record of all the changes of these organisms? There should be more transitional forms than the forms of whatever organism. There should be many forms leading up to it, but we don't have that for most things. Phylogenetic trees are a mess. That's the number 6. I have not presented this before, but I've talked about it. But basically, if life diversified from a common ancestor, then we should have a tree that matches with morphology, with genetics, with proteins, with various features. And instead, we have a mess. And the morphology doesn't always match the genetics. The proteins don't always match either one. There's in every phylogenetic tree that I have looked at, there is always contradictions. Convergent evolution. Convergent evolution is just a code word for a contradiction in evolution. So The trees are a mess. Okay. And it's very hard. It makes you go to ridiculous conclusions when you try to put these trees together. So that is my other scientific reason for rejecting evolution. And thank you everyone for being here tonight. I appreciated you. I didn't get to watch the comments as much tonight because I was really focused on listening to the guests, but I appreciate all the people who were here. Thank you guys for your comments. Thank you for your support, and have a great night.